Madam, good evening, madam. Resource person join, madam.
Good evening, all the participants. Now I request Dr. Airala Sunita Madam to take over this session. Madam, over to
Thank
you.
you, madam. Madam, am I audible, madam?
Yes, madam.
Respected Head of the Institute, Dr. C. Nadamani Reddy Garu, Head of the Department, Dr. Nayanar Pushpalata Garu, Coordinator Pasupuleti Harish Garu, and Tech Support N. Dilip Garu, and dear all the participants, good evening to one and all. It's my great pleasure to invite today's speaker, Mr. Kesavan K. Mannar, Engineering Manager from LinkedIn. Welcome to our session, sir. Over to you, sir.
Yep. Right. Share my screen. Can you all hear me?
Yes, sir. You are audible, sir.
Okay. I hope you all can see my screen too.
Yes, sir. Screen is visible and you are clearly audible, sir.
Wonderful. Good evening, everyone. For people who are new here, who have not been here or who didn't know we did not get a chance to meet yesterday, welcome. And for people who are returning, welcome back. So today, okay, I'll skip my introduction. I'll directly go into today's topic of okay. Okay. So today's topic is interdisciplinary collaboration in AI and embedded systems. Um, I felt this was a little challenging topic. It's not a specific subject, it's how two disciplines that's at the industry level disciplines, right? AI and embedded systems. AI and embedded systems internally for faculties and teachers could mean multiple departments: computer science, mathematics, electrical, electronics, subject matter experts, all coming together. So I felt like it was a nice topic and it was a little challenging topic as well. So it is going to be a little theoretical. So, uh, you know, bear with me, and as we go through this together, we can keep this session also interactive, so that we can try to address some of your common questions as much as I know, and we can also see how industry does it, from how things are handled at large scale companies like LinkedIn or even outside. So anyway, the topic today is interdisciplinary collaboration in AI and embedded system. I am excited to walk you through how different disciplines and intern departments come together to solve impactful problems using AI and embedded system. Let's get started. So I wanted to start here with a big picture, right? It is always important to kind of have the big picture, why we are solving what we are solving. So let's start by looking at the big picture here. Why should we care about merging or interacting AI systems and embedded systems together? First of all, it allows us to create real world solutions by combining strengths of both fields. Second, it bridges theory and practice, making our innovations impactful. You might have all gone through a lot of ML, and we have kept wondering what's the use of probability, what's the use of statistics when we go through during our school and college days. So this is the place where actually the theory meets practice, right? All of those things that we've learned either in mathematics, basics, are all coming together, and we're seeing how it is actually impacting such a huge field like artificial intelligence. For example, how AI embedded systems can revolutionize smart cities, autonomous vehicles, disaster response. You see CCTV cameras everywhere, right? You see a lot of embedded AIs across all around you. We just, it just becomes a part of our day-to-day life without even we noticing it. Um, so, like yesterday, we'll keep this session interactive. And please do leave a note in chat on what you thought were like, hey, I did not see this before, and I think this could be embedded AI. What are the things that are around you in your college, in your community, that you see are embedded AI, embedded systems and AI coming together? You could have seen a kiosk, you could be seeing a touchpad somewhere. So please do leave a note in chat on what you have seen as embedded and AI coming together. Now, we've sought the big picture globally, but now let's also see how it is relevant locally and what are the trends. Now, in India, for example, we face unique challenges like precision agriculture, affordable healthcare, and energy efficiency. AI and embedded systems can directly address these problems. For example, edge computing. Uh, just a second. Can you also just, so you're seeing the slide deck as a screen, right? If somebody can confirm, that'll be great. You're seeing the slide deck with big picture too?
Yes, yes, sir.
Yes, sir.
Okay, wonderful. I just want to make sure that I have two screens. I'm just sharing the right screen. Okay. Um, okay, so in India, we are facing unique challenges with respect to agriculture, healthcare, and energy efficiency. And AI and embedded systems can directly address these problems. For example, edge computing. AI running on local devices reduces cost and power consumption while also providing secure and fast solutions. This trends, and I mentioned it yesterday also about like RAG, fine tuning, and also AI agents. Just yesterday, OpenAI, the ChatGPT parent company, they've released something called Operator. I'm sure. Please do look up about it. But these are all like not necessarily edge AI, but these are the advancements happening on the AI agent side. Now everybody can get a personal assistant. Think of it that way, right? If you've seen the movie Iron Man, there is this whole science fictional character called Jarvis. Imagine everybody getting one, like just like your Alexa or Hello Google. So that is what is happening as we speak. So these trends are shaping the future, and this is where being on the academic side and being having students at your they are your energy as well. So you this is where you come in and you can do a lot of change in the community and globally as well. So, so now I just like I thought like I'll start just also I'm also waking up, so I'll start with a question for everybody. What do you think is the first thing that AI accomplished in its history? Right. Uh, you see the options. A played a game of chess, B solved mathematical equations, C composed music, and D translated languages. Um, I'll take like 30 seconds. Please do leave. Yeah, what do you think is the option? I tried answering this question and I did not get it right first. Yeah.
Game of chess, sir, I hope.
Yeah. Okay. So thanks a lot for your participation. Um, the answer is actually surprisingly D, which is translated language. Um, I'm curious, can one of you who thought it could be D, could you come online and maybe and share your thoughts on why you thought it was D?
Sir, AI is a system that is a man-made language. It will be converted into machine language, sir.
Okay. Okay. Um, so I think that's a very good answer too. So it happened in 1954. That was like the answer. I was like, surprised, but then the timing that it had actually happened, I was blown away. So the initial concepts of AI coming in so long ago, before even we, landed on the moon. So yeah, it was very intriguing, and I thought I'd share with you all. Okay. Now, I think we touched upon yesterday some of the core concept. What is AI? What is embedded systems? I just wanted to kind of quick review of what the core concepts of AI and embedded systems are. So before diving deeper, let's just take a quick look at it. Um, AI includes the areas like machine learning, computer vision, NLP, or natural language processing. These are software focused. On the other hand, deal with hardware, like embedded systems deals with hardware, microcontrollers, sensors, real-time, uh, processing machines like FPGAs and all of those things. But put these technologies together, and you can create, like, even for a low cost, a smart powered cameras. Like, I can clearly tell you, with the power that many people might have remember in our olden days, we used to have this cycle with a small battery powered lights. It's not necessarily battery. It's the some of these lights used to get generated from the light source gets comes from the heat that is generated between the while riding the bicycle. So you can run a machine, a small Arduino based on that, which means that you can power some systems to do some sensors and whatnot. So this is just two important and systems and disciplines that are coming together. So we'll understand how these disciplines collaborate. So both of these systems in today's world, everybody who's either doing in developing AI models, or is either fine tuning it, or is either coming up with a device which can actually, have AI in it. So this is where the magic happens, collaboration. So AI experts develop algorithms, embedded engineers, like for example, what are the various departments that come together? Computer science, when we said AI systems, or mathematics. Colleges may not have data science, but in all over the world, all MS and even many of the bachelors, now they're directly giving courses, or even certificates, or even degrees for data science. And this has become one of the this is when I studied computer science was or ECE was one of the biggest thing. Now data science, analytics, MLAI are the core subjects that are coming up. So these are individual departments on many colleges, and I'm not very sure how things happen today in your colleges, but I'm sure in 5 to 10 years every college will have these things. So then embedded, like, develop algorithms optimized for resource constrained environments, build predictive models tailored to specific domains. It's very easy in most of our computers and laptops. You should be able to build a model. It will be a little slow, but do take some time to try it out. Embedded engineers, which means electrical engineering, electronics engineering, to some extent even mechanical engineering, depending on what kind of, like, if you're building a robot and you need motors and stuff. So they're coming in handy too. Design hardware that supports AI models in real world use cases. Integrate sensors and optimize systems for energy efficiency. As I said, in spite of all of these things, the one biggest challenge all countries, and there is a race going on, is energy production and energy consumption. So, um, so AI experts develop models and algorithms, and embedded engineer design the hardware, and domain specialists ensure solutions meet real world. This is where all three have to come together to form a meaningful, impactful product or solution solving real world problems. So yeah, this is even more important in today's world to collaborate and share ideas and whatnot. I also wanted to take some time to share what are the tools, what are the platforms and communities that are active and growing in the space of AI and embedded systems. AI, to get started, I just shared some of them. By no means this is comprehensive. By no means this is supposed to cover, this is all like it could be when I do it. These are the things that I have looked at to some of those things, and some of those things came up during my research for this presentation. So you might all familiar with TensorFlow, Jupyter Notebooks, and PyTorch Mobile are perfect for resource constrained devices. Embedded platforms like Arduino, Raspberry Pi are very affordable, and anybody can start with that. And then the most important thing, I've listed a bunch of communities as well. Hugging Face has a lot of open source models, and they have a lot of metrics and measurements on how good a model is, what model is fine tuned for what, the diffusion models, and so take a look at it. Encoder, decoder models. There are a lot of these various things. What to use when. Um, it's a very brand new field, been up for 2-3 years, popular now. So it's not too long, but there's a lot of activities going on. So please learn organically, learn the fundamentals. I'm not saying go start figuring out, go back to, I'm not saying go back to learning probability and statistics for another 1 year. No, just make sure to understand what is a neural network, and what when they say bias or weight, what does it mean? So make sure your first principles are right. Even in India, I saw this NPTEL. There are many online courses, and they've started, there are many courses on AI and embedded system too. I personally like deep learning. I think I did not add it here. There's deeplearning.ai, and I'm doing I go through, I'm even going through the agent course right now, but you should definitely keep your learning active, and that's the only way to keep up. Um, so, so moving on. Um, have you used, I'm curious, has anybody used any of these tools that is here? I'm curious and I'm eager to know, and you sharing might also motivate your colleagues and friends.
I used Arduino and Raspberry Pi for experimental purpose.
If you don't mind, what have you built using that?
Students have
We are
interfaced sensors and collected external environment parameters has been sent to cloud through Arduino or else Raspberry Pi for the analysis of external environment, or to get statistical data, to analyze those things through cloud. Raspberry Pi model 3B plus, there is a model. So it has a 40 pins has been there. So
Right, GPIO pins. Yeah.
yes, GPIO, DHT11 temperature sensor, and air quality. So different experimental analysis has been undertaken
Yeah.
by students around 2 to 3 years. I have an experience on it. And Arduino also has with the cloud. Also, we have been interfacing. Is also happening. And the Tinkercad is, I think it is a virtual simulator where the students are similar, all interdisciplinary. I think this Tinkercad and Proteus, these two also has been. That's it from my side.
Wonderful.
Kesavan, sir. So this
Yes.
is Dr. Sunita, sir.
Yeah,
So
hi, Dr.
BTech students are doing project works. As Dilip sir said, if any students are doing prototype model, we are motivating the students to use Tinkercad tools, sir. If any students are doing simulation models, Kaggle dataset is useful for validation of their models, sir.
I see. Wonderful.
That's it from my side, sir.
Yeah, wonderful. Yeah, even in my house, my wife is a hardware engineer. She is a director of emulation on the hardware side. She was at NVIDIA and stuff. So even at home, we have the time we try to talk with each other, but we feel like our the languages the hardware people use versus I've been a pure software engineer. What we use is totally like it's mind blowing, and then there's so much to kind of like so much gap between hardware and software in general, and now
So
with AI.
your family is also collaboration of AI and embedded,
Exactly.
sir.
We do that every day, but still, like just by even being on the field, and she is now in a startup. I'm in a system where company where we deal with a lot of AI and stuff. Still, every day there's new things that are coming up, and especially departments and faculties and students, you know the collaboration, and there has to be a forum, and I've talked about it in some of these follow-up slides. You have to have this forum or hackathons and workshops that some like every quarter or every department can have like once every quarter or once every 6 months at least to go through that. We are still going through that, even being here, because the developments are huge. um, so yeah, absolutely. Thanks for sharing, both of you. Yeah, I really appreciate it. Okay, moving on. Yeah, just to keep this thing going on. How does computational power of your smartphone compare to Apollo 11? That is the rocket which landed human like on the moon. Compared to the Apollo 11's onboard computer. What do you think? Do you think it's so some people might, I'll give you a hint, it is more powerful. Smartphones are more powerful. Some people were asking, like, is it even powerful? Right? Wait, what do you think? Twice as powerful, 10 times, 100 times, 1,000 times, or even more? Please do share your options in the chat. Please continue giving your answer. Um, I am gonna be a little, um, you know, uh, I'll pick somebody. Miss Rohini or Dr. Rohini, you picked option C. If it's okay, can you say why you picked C? It is tough. It might look easy, but yeah, I want to know.
Maybe the advancements are 100 times more powerful. I think so, sir. Not 10
Wonderful.
times or twice, 100 times more powerful.
Right. Wonderful. Anybody who's picked D, can you please come online and say why you thought it's not 100, it could be, 1,000 or more? Somebody who didn't talk yet can come online if possible. It would really, you know, give you a perspective as well. Um, okay, I'm gonna pick somebody. I think Dr. Basavaraji
Yeah, sir.
Kurambale.
Because
Yeah.
of advancement in the IC manufacturing technology, the more powerful computer can able to have today in mobile phones.
How much do you think it is now? If it's over, how many, like, what do you think? Is it 1,000 times or 10,000 times? What do you think?
I'm thinking over 1,000 times, more than 1,000 times thinking, sir.
Okay. Okay.
Because exact formula I'm not able to predict.
You should. You all should probably know this. Like one way to predict is also Moore's law, isn't it?
Yeah, yes,
At least get a trend, right? It's like that's what they say, right? Every 18 months they keep packing twice as many transistors as possible, or ICs as possible. Um, but anyway, I'm gonna go to the answer in the interest of time. So it's actually D is the right answer, and the 1969 moon landing Apollo 11, the frequency was 0.043 megahertz. With somebody also mentioned in the chat about memory, which is 4 KB RAM, whereas today's smartphone frequency is over 2 gigahertz, which is over 1 million times, which is like 10, more than 10 lakhs times faster in processing speed. And I don't even want to mention, when we go buy a phone, when we buy a laptop today, we don't settle down anything for 16 gigabit RAM, whether we need it or not, whether it's for YouTube or not. We don't buy anything less than 16 gigabit. Or even phone these days are more than that. So think of this one, and with that computer, they landed a full rocket in the moon with people and brought them back. Imagine with the power we have today, what we can achieve. And 50, 60 years from today, when people look back, they're going to look at it as like, okay, how did they even run? We look at it today, how did people use tape recorder or something? It's going to look like that. So the future is bright, and it's only going to go a million times more, even bigger. So we are at a good time. It's not like a very passive time. We are at an amazing time, and India is also economically, politically, it's all in a great place. Geopolitically, I meant. So yeah, please encourage people to look around, solve real problems around yourself. Okay, moving on. I mentioned this yesterday as well, some of the projects to try. I thought in this whole thing that these are something that could be really applicable and could encourage, you could pick it up as your hobby project for your college, or even a semester project if possible. I wanted to introduce two frameworks in this session today. The first one is called STEP framework. This is mainly for faculties and students to use to see how, like, we can collaborate, right? And this is something that I came up with. So feel free to improve this, correct it. This is by no means, it's a, this is good. And like this could be a good starting point. And important things is to improve, iterate, try it, fail fast, try again, right? So as for simplify the problem, break down challenge into smaller parts, clearly define what needs to be done, also try to answer why, kind of helps you to connect the real world versus a product. Team up, and that's the core theme of this whole presentation, is to collaborate with people from different disciplines, right? Define roles of AI experts, hardware engineers, and domain specialists. Those three things have to come together. Experiment solutions. In startup world, and you in startup world today, everywhere, there's a whole mantra of fail fast. So it's important to kind of develop a quick POC, experiment it, let it to the field, let it get the feedback, and try again. Rather than waiting for 3 years to, nobody does it today. Even in a startup, the people release a product in 6 months, 3 months, and be for progress, and also refine, keep improving. So I thought it might be useful to pick one of the projects that we presented here, and see how we can use the STEP framework to try how do we go about it? Like, it's easy to kind of like go as a theory and say, hey, you try this project. I wanted to see how collectively we can try and come up with how to solve this thing. We can do it as a workshop here. So now you know the problem, and we said that the first step is simplify. can, and I want it to be interactive. So it would be really helpful if we can collaborate right now. So imagine if, this is the problem we are trying to solve and your college is ready to fund. How would you go about simplifying that whole problem statement? Anybody? Okay. I'm going to start with my theory of how I would go about it. It by no means is complete, but I would, for the next 2 or 3 steps, it would be really good if somebody can volunteer to talk about it. But I'll start. How do I simplify the problem? I'll first try to see what is the issue, right? The actual issue is like, first manual attendance is slow. It can, we've all grown up in a proxy attendance. There's a lot, and it's error prone. We miss stuff or we accidentally make mistakes or errors in taking an attendance. Um, and so this is the problem. It's the manual part. Anything that humans do is error prone or it's tedious or time taking, and time is money. How do we now solve this? Right. First, how do we break it down? So break it down to the simplest possible. Now, if you want to take attendance, you need to say that how do I identify students, right? There can be multiple ways. You can actually look at a face, or everybody can have some sort of biometrics, or everybody can have some sort of like, a RFID going on. Like, it could be in the future world, it could be an implanted chip. In the current world, it could be that everybody carries some form of device that RFID could be used. So how do we identify? That's the first part. How do we log attendance? What does it mean? Like, it needs to go sit in, like somebody was saying in the Raspberry Pi, they sent it to cloud. So you need a persistent storage, like a database. And then how do I handle exceptions when things go wrong, like, errors, or how do I handle privacy, right? Imagine if it's not attendance system and if it's medical data, your financial data, you don't want other people to do. Now, I'm sure you all have done a lot of projects in your thing and you've all enabled many people to do it. Now, somebody can talk about how would you, the T aspect of it, just the team up aspect of this is the problem. We have simplified it, we have broken it down. How do we now proceed next to the team up and collaboration step? What do you do? Any volunteers?
Hello, sir.
Yeah.
Hello. Sir, actually, in every institutions, we have that face recognition or thumb for staff attendance. Why
Yeah.
not that could be applied for students?
Yeah, that's a wonderful idea. Yeah. You
Staff
all have
attendance,
ID card. Yeah, that's ID card is RFID, right?
face or thumb is there right now.
Yeah.
If there is some problem, then it can be RFID can be used, that other option.
Absolutely. Yeah. Now, how do you team up? Let's say it's not there for students. Now, what do you do? You've said that, why not use the existing system? Such a wonderful idea, right? Why only for teachers? Why only for faculties? Okay. So now in my world, I would gonna now figure out that okay, if I want a smart face recognition system, like you said, or now everybody, if I want to have a face recognition system, I'm not sure if the system will scale. I want to first start with the RFID, which means everybody has an ID card. Like most people today, when you go to work, if you want to do first, what is the system? You identify the system, then put the necessary team together. Do I need an AI team? Do I need an ML team? Do I need an electronics and bring the right people or representative from their respective team? And you also need support from management as well, admin and faculty, not just for funding, but you want to try the system in their environment. Today it could be management. Tomorrow it could be the domain experts. Like you're coming up like colleges like Stanford, they come up with a lot of ideas and they dry run it in some of the bigger companies which are open to trying. So you might want to work with the domain expertise, and then you need volunteers you to try out your system. Hey, and we have seen this time and again. Anytime you go to a mall or something, people say, "Hey, can you try this?" So you need live feedback, and you want people to use it for 30 days and then give it back to you. So clear roles and constant communication with regular things to align progress. This is important in terms of the team up. Now, experiment and progress. That's the next two things. How do you go about, let's say we've decided, yeah, this is what we're going to use, facial recognition, we're going to use a camera. What is the thing that you want to experiment first? Because you don't want to you don't want to wait for 3 years to come back. Um, if anybody has any thought, I'll just give 10 seconds to wait for them. If not, we'll go ahead. Okay, so experiment with solutions. First, define a small prototype. Um, Experiment with prototypes, which is like first face recognition. Use a Raspberry Pi with a webcam with OpenCV. There could be minor details. Do you want a USB webcam? Do you want a PCI webcam? You can decide all of those details along with this. Now, if you're doing an RFID, now you want a RFID reader with student cards, like an ID card, right? So define what the prototype for the system is, and then build the systems in spite, regardless of the end goal. Build a very small portion of it to test whether this idea is feasible. What is missing? You might have to go back to that experts, bring that new team in. You're doing something robotic, then you need the mechanical people to come in. So you need to figure out what are the unknowns, what is missing, right? You make sure it's no different than cooking. Make sure you have all the ingredients available, then you have all the steps available, then you have all the necessary equipments available. So then run the test recognition's accuracy. And this is something that almost all of your machine learning course would say there is a training data and then there is a test data. You typically start off with that any course or any class is saying that take a huge data and then take 80% of the data as a training data. You run your neural net there or your algorithm there, tweak your accuracy, and then leave your 20% for your training set. Anytime you log in, let's say for linkedin.com or any other site, it says correctly identify the dogs in this picture. It'll give you 9 random pictures and you have to identify. This is all built by the machine learning. It knows that, okay, I am the language behind tells you I am 95% confident this is a dog. And as long as you click it, it's happy. It's happy. So iterate quickly, identify like the accuracy part of it. If it's poor accuracy, you might want to do it. We are all seeing self-driving cars come in all across the world. So how does it determine lanes versus road, signal versus humans? It's all the fundamental machine learning. And then applied AI on top of it with embedded system all over. I'll pause for if people have any questions in the step framework. Um, I can take up this. This framework is very simple, at least in my mind. Oh, sorry, I did not cover the progress and refine. So it's not just enough you build a prototype, you test your accuracy, you need to get real feedback. It's like you go to the field, you give it to a bunch of teachers in a college environment or tutors and check for the accuracy. It's a constant process of validation and reiteration to make sure it meets certain standards for you, for which you would have defined it upfront that I need a minimum of 95% accuracy. Improve the accuracy for edge cases. What happens when the lighting is poor? What happens when it's raining? And what happens somebody like, when accidentally connectivity issues or something, if you miss scans, what happens? Define it. You may not handle it, but at least define it. And then simplify the system for ease of use. This is the art more than a skill. Is that how do you make a user interface very simple? We have seen many companies survive or not survive just based on how the mobile app's user experience has been. So you can do all of those things once you've gotten to the last phase. I usually tell my team solve, optimize, and then beautify. So first you need to solve, for which you need to know the real problem and come up with a good scalable solution. Then once you've done it, then scale it up, like optimize it. It was running for once and it took 10 minutes to run. Now it needs to take 1 minute to run. How do you optimize? Then beautify it. So this is the one that we tend to follow ourselves as well. If any questions on this framework or anything so far that we have done. Okay, I thought it'd be a good thought experiment to take one, for example, smart attendance system and then build a face recognition system on up. Now, what do we need for building a face recognition? What are the hardware requirements? And this is one of the first is when we said simplify the problem and we say what are the teams involved. And then when we actually went into the execute step, we kind of said face recognition, use Raspberry Pi. Now I'm just taking one particular thing and double clicking on it and then trying to see what it means. What does it mean by building a face recognition, which is part of the experiment step? What does it mean by building a face recognition system? What does it take? It at least needs a Raspberry Pi, a compute power. It needs a camera module, the physical device which captures the like the student's face or faculty face. Can be, like I said, it can be a PCI cam, it can be a USB cam. You need to figure that out depending on your environment, power consumed, latency, all of those things that we've discussed yesterday. And then you need storage. What is a typical size? What's the camera resolution size? What will be an image size? Do I need compression? Will that compression be lossy or lossless? What kind of encoding do I use? Right? Now then, how do you go about building it? Then create images. Use the Pi camera or the USB camera to collect the photos. In a typical camera recognition system, in case of a biometrics, somebody goes and presses the 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 touch device, then it knows that okay, it has to recognize. In case of a camera, you're not gonna somebody's not gonna be on the other side sitting and clicking. How do you know when to capture? You need a system to initiate the trigger. Now, let's say you've done all of these things. What is the model that I run against, right? Do I know that this is like 80%, 90% accuracy? So there are many pre-trained libraries, OpenCV, face recognition to generate face encoding. So first you will have to run, you either upload their photos that are already there, and that hopefully not more than 6 months old photo, and you create a whole, and then you keep training your model on all of those. And that's where you train on 80% of those photos, and then you try to apply for the remaining 20%. Does it clearly identify those other folks as well? So recognize, then go to the actual this is where the new, there is a term, this is where rubber meets the road. You buy a car or a motorbike, it's all good in the dealership, but when the actual device hits the real world, that's the real test. So does it match, a real face with the trained encodings? That's the 20%. What are the various tools that can be used? Python, OpenCV, face recognition, DLib, and some sort of live databases. Um, and today in database world as well, um, and in AI world as well, there's a lot of talk about short-term memory, and interestingly, a very funny name, long short-term memory, LSTM. There are many such improve, things are happening there. You might have heard vector databases. Um, Companies like Pinecone, ChatGPT or Gemini is not just about answering your question. It also needs to remember. I'll do a quick demo of that at the end. It also needs to remember what are your interests, whether it is education, whether it is healthcare, it has to be catered to you, right? Every personal things. Um, what is your strength? What are your weakness? And they should focus on, if it is an education system, it needs to focus on the weakness more. It has to be tailored to you. And it was not possible by all these Byju's or all of those things because they are just doing a general purpose teaching mechanism. Now AI comes in. AI will take your favorite form as a teacher or a motivational personality or a voice, and then it can cater to every single individual. That's where we are, and it's not far. This is happening right now. So, yeah. So, so Python, OpenCV, all of those databases and stuff. Output, is it automatic recognition? If we automatically recognize, where are we logging it? Like somebody was saying about, they do it in cloud or do it on the local DB, and that has to be decentralized as well, right? The recognition has to happen decentralized, the updation has to happen in a centralized system. So have to figure out a lot of various things. So the moment you start breaking it down and giving it to the respective expertise, the experts comes and starts writing all of these things down. It is hard for somebody in one discipline to understand all of those things, but that's where the collaboration happens. That's where the alignment happens. Hey, this is when I will finish it. What do you think? And you will operate like an actual company. When I develop something, that is the first thing that I develop is the first thing that is needed for anybody in the company. I build the entire network when we add a new data center. Without network, you don't have servers. It's like you can build however fancy houses, but if there are no roads to your house, it doesn't matter. Nobody can live there. Exactly the same thing. If I don't build the road, then think of my team builds the road. You don't have a house. If you don't have the house, you don't have a place to live. No AI can exist. So my thing is the first thing from procurement. We place the order all the way to building the end network system and running network systems at scale. And then how do we interact? Like when somebody says, "Hey, LinkedIn, we need a new AI," and that goes, you have to have work with like 10,000 people, but it's very hard to get 10,000 people. Then you break it down just like college disciplines, departments. We have various departments. You break it down. There are leaders who interact at their level, and then the next level of leaders interact with their level, and then certain pieces work together. Hey, network, there is which is like a road team versus a house team. Same way, network team and the server team, they work together. Hey, server team, hey, I need it by March. Their network team works on trying to get it ready before March so that they can start construction, like building the service on March. So these level of collaboration also helps you prepare yourself to and prepare students for the real world, how businesses work. It's not like olden days where when I came in, people were okay. I could take 6 months to understand the enterprise culture, a company culture. Today, when I hire somebody, I expect them to hit the ground running. I expect it's like getting on a running train or a running bus. I expect them to get on board as soon as possible. And kids these days are extremely intelligent and smart. They're able to do that. So you should also focus on how to get them ready, and you operating it that way like a company would also help. Just my perspective on that. I also have one suggestion framework for the management team as well. And I do highly encourage uh, the management team also to think about it. It requires management teams a lot of support. I was fortunate to have a great HOD during my time, and it was like, it helped me to think about it, problems differently, and propose ideas basically. So I have such a small thoughts on for management and administration and heads of the department. I came up with something called AIM, but this is just an idea. You probably can come up something for yourself that is suitable for you. So to make interdisciplinary collaboration, remember, if there is no interdisciplinary collaboration, there is no product and there is no meaningful product. You can individually develop something, but that may or may not be useful, right? Unless you work with other teams. So to make interdisciplinary collaboration successful, the administration, the management, the heads of department, they play a vital role. The AIM framework provides a simple plan for enabling innovation and supporting faculty and students. Well, let's go. I thought take the first step by creating opportunities. Create opportunities for your faculty, for your students. And I mentioned earlier, either host hackathons. We do that. I just finished one last week. We have hackathons and fixathons and stuff like that, and workshops to encourage teamworks across departments, right? And as a head or as a management, you will have connections to local industries, and that's how colleges like Stanford get lots of funding as well, because they go talk to, hey, let me try and understand your problem. I'll come back with some solution. I'll use my, and they go back instead of be asking the students to go figure out a project for themselves. It would be great if the department already has a list of projects which the students can pick from. So partner with local industries to bring real world problems into the classrooms. What do you think? Do you think such might work out? Are there challenges that you want? I'm curious to hear anybody's thought um, in terms of like what events or collaborations would enable you or your students in your colleges.
Sir, this is Pushpalata, HOD of EC department. We are encouraging students with the collaboration, such type of events, sir.
Yeah, in it. Thanks, Dr. Pushpalata, ma'am. During my time also, we used to have the symposium, but I can't imagine how it is today. But that was not very interactive. That was just that very like I did few things because my HOD was very supportive. But I'm glad to hear that you're already enabling people with these kind of things. So good to know. Thank
Yeah, thank you, sir.
Okay. The next step is innovate. And I cannot emphasize this one more, is that we need innovators, we need inventors, and it has to start from early days. I have a 6-year-old at my home, and I encourage her to come up with There are times most of the times I keep telling her, listen to me, but there are times I do tell her, don't listen to me, right? What do you think? Because the way they see it from very young age, and even to students, like, they might have a different way, especially in classrooms. And when they think that, no, I don't think that the theory, I am not able to understand this. I feel like they're either they really have lack some clarity, which may need some bridging the gap. There's also the things that they may see things differently, and all inventors have seen it differently. So please do support new ideas. One, again, this is to the management, HODs, and administration. Fund, whatever possible. Offer funding for small scale pilot projects like Raspberry Pis, whatever that is needed. It will definitely, people who are not able to do because of not having that, it'll enable them. Or just having that will just take out one extra step of procuring them or buying them. Simplifying, this is another thing. You might have seen the Modi administration have done a lot of these things, and I've seen this External Affairs Minister Jaishankar also talk about how India has opened up to the world, and then India has also opened up in terms of cleaning up the patent filing process. And in the last few years, I think they filed more patents than the last 30 to 50 years. It was very welcoming to see that it's not just you come up with idea, but you also have a way to register that idea and share the idea with the system while maintaining that, you basically a copyright, right? So encourage, as a part of the process, if you believe some idea is good, go ahead and look for how to file a patent, and to protect and also to promote innovation and invention. I'm curious, anybody, do you already, as a college or as a department, do you think about patents? Do you have you filed patents? I'm curious to hear anybody's thoughts on that. Or do you think that'll help? Okay. Thanks, Krishnam Sandeep Kumar. I do believe strongly, and I do encourage my team, even within a company, to say that, hey, solving a problem is important, but we also need to register the idea, share it with them, protect the idea, and then share it with the wider world as well. So next thing is like invest. So provide the resources needed to succeed. Offer scholarship for students working on interdisciplinary projects. It's again, we need more collaboration, interdisciplinary or interdepartment collaboration. So promote any such ideas, welcome any such ideas, have an open mind. Like I said, equip labs with tools like Raspberry Pi, kits, and sensors. If it's readily available, it could make anybody to go try things. Please, to the management team, to train faculties in AI and embedded system. It is so important right now, and you could make a lot of difference. The things that we learn today is not going to be the same as tomorrow, but without learning today, you cannot make that connection tomorrow. So I'm assuming you're already doing it, so please forgive me when it's not meant to be preachy, but I thought that these are one of the important things that, not just individual faculties, but the administration or the management. We also expect a lot from government, right? Could be that seen that way. And then mentor, guide teams, assign senior faculty members as a mentor. And in corporate world, we call it as a buddy system or a mentorship system. Even for faculties, everybody needs a mentor, right? The next level people, HOD acts as a mentor to the assistant HOD or the senior professors, and they act as a mentor, not just as a senior, right? Not just from seniority point of view, like mentorship, like, how do they get to that next level? How do they get better? That's only going to improve yourself as well. It'll help you to, if they don't grow, you don't grow. So it'll help you also to grow. So encourage these kind of opportunities as well. Faculty members to support student projects, connecting teams with alumni. Like you're exactly doing that right now in this 5-day program. You're connecting with alumni and industry experts for real world insights. So, so I think that I strongly believe um, the bridge between academic and corporate. Academic used to be a lot research oriented ahead of corporate. Now corporate is doing a lot of the research as well, and academics is behind. But it is very important that academics has to catch up and even overtake corporate world. And and that's only possible through interdiscipline collaboration. Anyway, I think I've bored you all. I think I'm, I think I'm made myself sleepy too. Um, I'm sure you're all sleepy as well on a Friday evening. It's I can't imagine. Yeah. So yeah, trivia time. Which of these incredible tasks has AI accomplished? Basically, you can say in near time future all of the above, but right now it's not. Translating dolphin sounds into human languages. Dolphins are the next best intelligent species. Generating synthetic human voices indistinguishable from real ones. Creating new chemical elements in lab, predicting earthquakes days in advance. I promise this is the last trivia. You can. Okay. I think, yeah, like most people, few people guessed, it is generating synthetic human voices indistinguishable from real ones. Um, can somebody come and say why? Why not like earthquakes and why not chemical? Why do you think this has been accomplished? And have you used any of those things before? Okay. So the systems like DeepMind's WaveNet and Levin Labs have created synthetic voices so realistic that they can mimic human speeches. You might have seen YouTube videos, and there is a good aspects. I've seen A.R. Rahman, people who passed away, he created music in their voice. But it's also, I mean, we might have seen last US election, people were imitating Barack Obama's voice. And in the future, it's going to be like there is a scary aspect. That's where ethical AI also comes in. It could mimic anybody's voice, your favorite, your loved one's voice, your family's voice. So we have to be careful too. But that's where the technology is going. So it's interesting time ahead. So that's basically it from my side in terms of um, uh, you know uh, the interdisciplinary collaboration. Um, any questions? This topic, any other topic?
Participants, any queries? There is a query in chat box. Human voice varies widely. They have different pitch, department,
Yeah,
etc. and all.
I do believe that's a wonderful observation, Sir Abdul Qadir. Um, yeah, I think there's so much variations and so much pitch that people do. We see it in singing or shouting. So, uh, yeah. Can you please tell us about the artificial skin that is developed for robots? Huh. Actually, don't know. Um, um, I'm not familiar with it, unfortunately. Sorry. I do think that there are a lot of synthetic proteins that people develop, but I don't know to that level of uh, this whole biomechanics and biomechatronics side of it. I'm not very familiar. Okay. Thank you all. Thank you all for attending today's session and for interacting, engaging, and keeping it interesting for me as well. And this discussion, especially about interdisciplinary collaboration in AI and embedded system. I hope some of the framework, it is simple and I've come up with it. You can definitely, I'm sure you can come up with much better frameworks. I always like to operate with frameworks, so I'm hoping you will have your own frameworks as a college, as a management, as a faculty. Um, and I hope whatever I shared will spark some new ideas, projects, and even partnerships at your institution. Um, Remember, every small step can lead to big impacts. So thank you once again, and I wish you all the very best in your journey to inspire, innovate, and solve impactful problems. Uh, that's basically from my side. I owe you all a thing from yesterday. I don't even want to do the chat. Anybody can come up with a small story. Um, we can have Sora generate a 10-second video. I developed it like, I gave it like, hey, give me an embedded AI in action. And I said, I gave it a small script, a screenplay. It has to come in, it has to see something. I gave a big screenplay script and it generated a 10-second video. You could see that it's supposed to be a smart attendance system. It just came up with that where students are walking in and then it seems like a very sci-fi thing. But if somebody wants to give some suggestion on what this is what I give. Sorry, this is the library assistant. Smart attendance, scene one, smart attendance system, scene two, there's a library attendance, and then the scene three is a smart notice board. I don't think it eventually did all of those things, um, but you see the smart attendance system coming and talk to the smart library system there. And this one is going and taking attendance while students are walking in. I'll just say generate, would like, or generate a video to say thanks to a wonderful audience in a futuristic or a sci-fi world for 10 seconds. You can give a much bigger script too. I just wrote it. It's no different from. Sorry, somebody. Did somebody wanted to say something? Sorry, I'm looking at my monitor. What was it, madam?
Hello, sir. I'm audible, sir.
Yeah.
Sir, shall we combine AI with embedded system for any medical image analysis, sir?
Oh, yeah, 100%.
with respect to medical
100%. There is
instrumentation
already,
devices.
yeah, I can show you this one, YouTube. Um, you see this Da Vinci surgical robot, Da Vinci surgical robot, and you see this. This is 7 years back, and you see the latest is also amazing. The way the surgical robot does this is seven.
Hey, we can we have an XI and an XI. We'll talk about, like use to go with them.
My kids see this
Help the
incident with
nurses out
Rajnikant
with
movie,
no
and this is this
knowing
this that's
and
amazing stuff.
back of the these handlebars are basically just too big.
So not exactly this one, but I saw few videos where yeah, exactly this one. This one.
4 robotic arms. One holds the endoscope, a thin tube with a camera at the end. The second, third, and D images inside the patient's body. Movements of the endowrist instruments, which bend and rotate far greater than the human wrist. Combined, these features enable Da Vinci trained surgeons to operate with enhanced vision, precision, dexterity, and
Imagine this is 10 years back. And now this was pre-AI days. Now AI is here. And there have been recent papers where AI is able to diagnose and detect issues just by looking at certain images, like whether it is um, cancerous cells or gene sequencing and everything. So this is the future is the potential is amazing, and the velocity, the speed at which they're gonna start identifying diseases and curing diseases are gonna be crazy. So I hope that did answer your question. Uh, I think Dr. Pushpala, but this is what it came up with. I said it ended up saying that, okay, whatever I asked for as futuristic robot celebration, like, it looks
Thank
like
you,
it's
sir.
getting faster. So yeah. So anyway, that's it from my side. Thanks for the opportunity, and I hope you all have a wonderful weekend as well. Why?
Dilip, sir.
Yeah, Doctor. Yeah, ma'am.
This is Dr. I. Sunita, sir, Professor of PCA. Sir, thank you so much for your insightful presentation. Right from beginning with the components of AI department separately and embedded systems separately, and also for covering the topics of visionary projects using AI, trends of AI, collaboration of AI in different disciplines, framework for collaboration management team, AI, MMA, as well as in between your presentation also, you make all the audience to be interactive by giving question and answers. And also by the end, you have given a wonderful video for my doubt also, sir. So once again, thank you very much. We're expecting your physical visit to our institute also during your visit to our India, sir. And thank you once again, sir.
Yeah, thank you.
Sir, this is Dr. N. Pushpalata, sir, HOD of EC department.
Hi, hi, ma'am.
Actually, I thought it is a silly question, but anyways, I want to know the answer from your side, sir. Previously, I saw one WhatsApp notification, some Facebook like that, sir. One robo which gives birth to a baby. Is it really true or not? I do not know.
I can easily generate a video asking, can you generate a video where robot gives birth to a baby? So unfortunately, I don't think it's not advanced that way. We have a very scientific way of, I mean, even in our past, all what we used to call test tube babies and everything. There are many, but unfortunately, there are still humans involved in all of those things. But you could envision the futuristic world where it doesn't necessarily have to be another human carrying the baby for all through the environments. And this is what you're talking about, simulator and emulator. How much ever it looks sci-fi, it may not be an immediate need, but I think it's the movie, what was that movie, Salar, or some recent movie, Telugu movie as well. I was really fascinated by all the futuristic things that they've mentioned in that movie. So, and um it is not there today, and the immediate problems are not that, but I'm sure gene sequencing, all those things are happening right now. Cancer, curing cancer, those are the stuff that are happening. And this is, I think, Abdul Qadir, to answer your question, I think advancements are happening in every field. Some make news, some don't make the news yet. But if you come to here in US and especially in San Francisco, many cars self-drive, like many taxis, they drive by themselves. And I am in this field, not necessarily AI, but I'm living there. I still feel very fascinated and sometimes scary, or to see that a car driving by itself, somebody gets in, they get dropped somewhere, it car drives by itself, and it's not just within a college or something, it drives across the whole San Francisco city.
Okay. Thank you, sir.
All right.
Thank you, sir. Kesavan, sir. We noted that your name also have written smartly. K7, Kesavan,
Yeah,
sir.
yeah,
Thank
yeah.
you once again, sir.
Thank
On
you.
behalf of our entire institute and department and the AICTs.
Yeah, thank you all, have a good weekend.
Thank you, sir. I'm Dr. Harish, sir, organizer,
Hi, sir.
coordinator. It's a very, we're having a very nice session, sir, these 2 days, and we have gained a lot of knowledge from your session, sir. Thanks a lot.
Thank you. I'll do share both of my presentations to that email that you
Yes,
sent
sir.
me,
Yes, sir.
and so that you can use it. All these images are all AI generated, so there's no copyright problem there.
Yes, sir. Yes, sir. We also will try for future presentations, which we
Yeah,
have.
I've done a lot of presentation, but this presentation was very special because it looks special because of all the images, colorful images and everything. But I'm not that good at presentation. AI made it like this is where AI helped me.
Which are very attractive, sir, which are grabbing attention.
Yeah,
Slides are
absolutely.
grabbing attention.
Yeah. When I wrote it, I said like, okay, I know people are. It's after a day's work. It's gonna be tough, but how do you engage audience? Give me something motivational, and it's all AI. Yeah.
Yes, thank you, sir. Thanks
There
for
was I read something and I want to share this. AI may not immediately replace humans, but a human who knows or who uses AI is definitely going to replace another human who is not using AI. So whether you are in an AI field or not, you have to be aware of it. Think of AI as like a motorbike or a cycle. It is not a special field. It is going to be there in every field. So
Sure, sir.
regardless of your
Sure, sir.
discipline, you need to be
Yes,
part
sir.
of the AI dialogue. So
very valid points, sir. Definitely, it will be going to be, sir, in the future. That definitely human with the AI knowledge will replace the human. Definitely, that's one. A very good
yeah,
quote, sir.
yes. So yeah, thanks for your time. Thanks
Thanks.
for
Thanks for
listening to me on a
your
Friday evening.
time, sir. Yeah, thank you.
Thanks. Bye bye. Take care.
Yes.
Thank you, sir.
Welcome, Lakshmi Madam.
Yes, good evening, sir. Good evening, professors.
Good evening, madam.
Good evening, madam.
Good evening, ma'am. Good evening, professors. Yeah, shall we start? Is it any other formality or shall we start sharing
Just
this?
one minute, madam. HOD, madam. HOD, madam.
Tell me,
Can
madam.
I initiate? Can I initiate, ma'am?
Yeah, madam. You can.
Am I audible?
Yes, madam. Yes.
Madam, respected head of the institute, Dr. C. Nadamuni Reddy garu, head of the department, Pushpalata garu, coordinator Harish garu, tech support Dilip garu, and dear all the participants and today's resource person. Good evening to one and all. On behalf of our department, we are welcoming Dr. D. Lakshmi, Professor from WIT Bhopal, to develop the topic on AI for predictive maintenance in embedded system. Welcome to the session, ma'am, and over to you, ma'am.
Yeah, thank you for your welcome note, ma'am. I shall proceed with sharing the screen, then we can start. Hope so it is visible. Am I audible? Then if both are comfortable, we can proceed with.
Yes, ma'am. You are visible and clearly audible, ma'am. Your screen is visible. Fault
Thank you very
detection
much,
and
ma'am.
diagnosis.
Yeah, thank you very much. So the same material, once again, I will be sharing it for the benefit of audience, those who missed yesterday. But day 2 topic is different. The document is same, but the topic is different. AI for predictive maintenance in embedded system. So very minimal material only available, especially for predictive maintenance in embedded system. In general, it is available. Predictive maintenance for turbine, wind turbine, predictive maintenance for industrial setup, predictive maintenance for freight services, predictive maintenance for so many other domain available. Maintenance in embedded system. This what way we can take, that is the next question. For example, complete smart grid. Let us imagine electrical grid. So recent day people are calling it a smart because of the use of IoT sensors and some extent of machine learning and deep learning. Because of this all, it is said to be smart grid system. In India, they are migrating, they are slowly bringing to the machine learning and deep learning and advancement. For example, smart electricity metering nowadays available. So automatically it is maintaining the previous total accumulated, the electricity unit consumption, this month consumption. So everything is transparent nowadays. Similarly, within the grid, fault maintenance. This topic is exactly fault maintenance, fault prediction, not after the occurrence of fault, before the occurrence of fault, or immediately the moment the fault is identified, how the human being will become to know, how we can go for maintenance, how it will be replaced, what are all the way to get to know well in advance, or before even failure. Definitely every sensor or every methodology or every hardware component will create the wrong data, will deviate from the normal functioning. So how that deviation can be predicted well ahead, or at the time of fault, how quickly we can fix. These are all said to be predictive maintenance. In this case, another way I am bringing, embedded system is deployed. So for example, smart grid or the wind turbine, one turbine or multiple turbine can be coordinating. So is there any problem with the fleet, or any problem with the motor, or any problem with the turbine? So something, these all monitored, the data is analyzed and data is periodically verified, and it is providing alert or health of that complete architecture. So this entire prediction, we can keep it in embedded system, any one small device that will be part of the smart grid, or that will be part of the wind turbine tower. So the wind turbine tower is too huge. So we can deploy this small embedded device, any part of that wind turbine. So this is how available. Embedded system failure itself, that way I am not able to find. So for example, we are keeping one embedded system, whether that embedded system is going to fail or about to fail, that prediction is very, very rare. I am not able to get. That's it. So we can deploy one embedded system for every big industrial setup, even flight, even the ship. It has to be, a ship has a lot of components. One time, if we watch YouTube video, how the ship is sailing in the sea wave, in the dangerous middle of the sea, how it is sailing, that all if we see, then we will come to know. Then a lot of solid rock and icy area, complete ice iceberg will be there, so it may hit. Then these all some of the problem. So anything is failure, middle of the sea, middle of the ocean, what will happen? So for that we can bring one embedded device wherein which all of the sensor data it will be collecting, and it will be analyzing, and it will be taking decision whether there is something wrong going to happen with the flight or with the ship. Quite often we are reading article. Recently 2 flights in the international flight disaster, bursted and burnt, completely burnt. So why it is? Where the leakage, which part has failed? So that all need to be periodically verified. Even the train, everywhere people are checking all of the major component manually, sometime automation, sometime fully automation, sometime partially automation. So that is said to be predictive maintenance. Why we are using AI? If there is no AI, yes, even then all of the maintenance were existing. But when the human is periodically going and verifying, the operational cost is more, number one. Then we need to shut down the system. We need to verify. For example, the flight is landing for 20 minutes, unloading, then another 20 minutes loading. Within 45 minutes to 1 hour, the connecting flight is started flying. Rather, if the automation is not there, if human is stepping and troubleshooting every landing and every takeoff, how much time will take? Every component we need to do. By the time the human being mind is in upset, then some component if the human is not checking, total disaster. So these are all the circumstances we are going to replace it by AI. It doesn't mean that without AI we cannot do, we cannot maintain. Already people were maintaining, human only controlling all of the services, flight services, freight services, all of the services they were only controlling. Right now we are taking advantage of not to rely on human. So automation, speeding up. So these are all some of the way we are, or we need to find out the fully skillful human for predictive maintenance. Especially assembling also we can train someone, we can easily make them to assemble the car, assemble even train case, train engine, assemble anything. We can train any novice learner, a new learner easily. But maintenance is little tough. Maintenance can be done only by the expertise who is into the field. Then skillful labors or shortage. Then the cost we need to pay to the skilled person will be highly demanding. So that is why, say for example, fresher, BTech 3rd year, 4th year, if I hire, they have fresh brain, nothing they know practically too much into the field. So I can train them. They will be patiently listening. They will be having a lot of enthusiasm in learning because they are beginner, no ego, deep rooted. They don't even bother about the salary negotiation. Whatever we fix, then with that they will be taking that appointment and joining. I can train them easily. Within 1 year, they will also be expertise in car manufacturing or anything, wind tower manufacturing, lorry manufacturing, anything they can become easily acquainted. But once if the person becomes highly skillful, lot of cost involved in it. This is the preamble or background I'm creating. Why predictive maintenance we need to rely on AI. That's all. This is the justification reason. Now, what is fault detection and diagnosis? This is otherwise said to be fault detection. First, it has to detect and it has to diagnose periodically, well ahead. These are all some of the words we are adding to the AI. That's it. Predictive maintenance in short form, in all of the research journal, people are using PDM. This is what to say, abbreviation like they are using it. So how artificial intelligence is playing a role? The moment we say artificial intelligence, machine learning, deep learning, generative AI, listen, artificial intelligence is a big domain, including theory. There are several algorithms available for AI in terms of mathematics, in terms of theoretical, but not possible to implement. There are most of the algorithm people have brought into the existence. So AI is a big picture. theory, mathematics, whatever existing phenomena in practical, all together it is AI. Within AI, machine learning. The subset of machine learning is deep learning. The subset of deep learning is generative AI, Gen AI. Now this is the way subset started emerging. The recent couple of years, maximum 2 years, 2023, 2024 only, generative AI people started coining that word. Then that is one area it is keep booming. And within beyond generative AI, lot of other AIs, AI agent, what is synthetic AI, so many AI is revolving around. A lot of new technologies are emerging day by day, not even monthly basis. So that all let us keep aside. Now, whatever machine learning, deep learning, generative AI, everywhere demands data. Data is the primary focus of machine learning, deep learning, or AI. That's all. Without data, nothing can be done, nothing can be implemented. That we need to keep it in mind. Then, how to get the data? Number one, secondary source data. We may need to find the reliable data. Somebody is donating lot of data repositories. See, just look at Google. Then, what to say? IEEE portal is bringing lot of validated data. Now, Google has data engine. Google data engine. It is maintaining plenty of data engines with respect to different domain. Look at manufacturing data engine, earth data engine data, healthcare data engine, Google Earth engine. It is maintaining lot of engines. As of now, I have shown 3 engines, lot of engines. We can find plenty of data. Just I am clicking manufacturing data engine. It will have plenty of other data point. We can download AI driven operation optimization. This is also one of the part of predictive maintenance. So how we can smoothly the operation, we can make it to happen. Optimization, automation, these are. So this, it has plenty of data analysis, price, they're selling. Nothing is for free, I guess. So a lot of data engines available. People are donating voluntarily. Lot of data journals. They are inviting data in brief. This is one data in brief. So this journal, if you look at, this is asking for data in brief journal. We can donate a data, articulate about data. Sorry, I have typed wrong. Data in brief journal. See, impact factor. Initially, it was not Scopus indexed. Now they have started. This is data in brief. We can generate any data, chemistry department data, electronics department data, civil department data. For example, VIT Vellore, they have generated data based on whatever the battery they are having in their campus, that battery decline, that lifeline decline, battery usage, battery efficiency, these all they have calculated, they have generated that data, they have deposited, analyzed also. Just donating data, you will get Scopus credit. So data in brief journal. So you can generate any primary data. That should be unique, not existing one. So for example, smart grid data, already government agencies, they are generating, electricity board is generating. You cannot go and add one more variable. I have brought something new, not at all available in this world. For example, agriculture data is very minimal. Cotton, variety of cotton, whatever available in India, related to that you can generate. It could be anything, that is your choice, you can read it. So nowadays, donating data, explaining about data, what experimental setup you have done, or how did you collect the data, and what is the meaning of data, what is the interpretation, what is a range. So all when we write together in terms of journal structure, then when we submit it, we are getting Scopus index. No novelty, you don't need to do research, nothing. So this is what happening. Primarily, we may need to get the data. That is a baseline fuel for driving the AI engine. That's it. Now, before AI, or what are the possible maintenance technique they are using? R2F, run to failure. After failure, only people can understand something gone wrong, completely down, shut down, power failure. Suddenly, smart grid is not functioning. Then 2 days, the entire city should live without power. That is a downtime problem. To overcome the downtime problem only, we are stepping into AI. Now, that is the first step. So disaster has to happen. After that, only people will go for something corrective maintenance or unplanned maintenance. Then predictive maintenance. What it is? Predictive maintenance, scheduled at period. 10 days once we need to check, oil need to be cleaned, whatever, something, the heat generated by that machine need to be verified, something like that. Every corporate or every sector, people are verifying periodically, scheduled based or time based. That human need to intervene, they need to verify. That is the way. Then next is condition based maintenance. So now how they are doing, in which constant machine or equipment monitoring or their process health that can be carried out only when they are actually necessary. Only at the time of necessary only they will do, no schedule and all. So something going wrong, the data point is becoming wrong or low, something kind of some conditions they will be observing, certain actions they will need to take upon the condition. That is also usually cannot be planned in advance. These all such kind of machineries we cannot even do AI. That is what again another choice. We need to go with a conventional system. We cannot expect everywhere we can apply AI. So that we need to strategize. The moment we use PDM, that word starts with simple statistical based maintenance. Statistical based analysis also possible. Simple Z-score analysis, it is available. Z-score, when I put it in internet, it will give formula. I have brought already one formula, Z-score. That let me check and show you. Z-score formula is available. Oh my God, totally the results are, this is a Z-score. X, any data point, my mark, let us imagine, my mark minus X mean divided by standard deviation. All of my classmate mark is used to calculate mean and standard deviation. How much I am deviating from the class performance? Xi means person 1 mark, X2 means your mark, X3 means some other person mark, like that. X minus X mean divided by standard deviation. The same is used for Z-score. It is otherwise called, it is standard scalar, otherwise called Z-score. Simple calculation on the Z-score of the entire data collection where it is deviating. The moment the deviation is obtained, that Z-score, how it behaves is, whenever the input is little closer to each other, it will give little closer to each other. How it is, the same value it will give. Whenever the value is something deviated, it will go to negative, or it will give something a different data point. So based on that, it is possible to detect. Z-score is one of the simple statistical model to identify the anomaly or outlier or extremity or something doesn't suit with the group. For example, in this group 141, let us imagine, I'm conducting a test. All of you are trying to get above 90 and I am getting 10 marks. Then this 10 is said to be extremity, outlier, anomaly. Only one student mark is something beyond the nearby cluster. Other way around also. All of you are trying to get less than 20 marks only when I am conducting a test. I'm the only person trying to score for that question paper above 90. Then I will be the outlier. Because rest of you all belong to less than 20. Whatever. Positive extreme, negative extreme. I'm trying to tell. I have applied myself in both of the circumstances. I applied you also in worst and best also. Nothing to worry. Cancelled each other. So now this Z-score will find out. When this kind of extremities will come, imagine sensor 1, sensor 2, sensor 3, vibration sensor, humidity sensor, temperature sensor, sound sensor. I'm using heat sensor, something. I'm using some set of sensors. Usually the sensor will give some same set pattern of values. All of a sudden, if it is changing and it is giving different value or no value, NA, not available, NAN, sometimes not available, NAN or NA, it will give, or empty, or different data, 0, something like this it comes, that is called extremities. These are all the alert we can do based on PDM. but we need to take decision based on only data. So whether we apply machine learning or not doesn't matter, but we need to collect data periodically. Through the data point, we can take decision. Directly, we can take decision. Value is not at all. 5 sensors not at all giving data. That seems something wrong. That sensor power failure, or sensor damage, or sensor whatever you can call it. So that because of that only, 5 different sensor values I'm getting empty or not available or NAN. Then another method, yes, I'm getting data, but it is entirely different from the usual pattern. Then we can apply simple, that formula only, Z-score. What is how? For example, I am having only one sensor. From the morning, I am analyzing today's data. So that data maybe once in half an hour, once in 10 minutes, that doesn't matter. That's it. So all of the data point, what it is trying to tell, X mean, then standard deviation. At this point, 8 o'clock, I'm trying to 8 o'clock data minus the today's entire data mean divided by today's entire data standard deviation. How much it is deviating. That is how it will predict Z-score. So using simple Z-score also it is possible for automation, that is called PDM. So that's it. Next is historical data. In all of this statistical data or machine learning, we need historical data. Historical data, otherwise monument data. What is monument data? Past history, past 5 years. If you sit and analyze your students' report appropriately, keenly, then placement report, what sort of skill, what sort of job people are going above 40 lakhs, above 20 lakhs, above 10 lakhs, above 5 lakhs. So what sort of skill set, what sort of job? That microscopic level, if you analyze using machine learning, it will bring the pattern. Pattern mining is one field is available. It will bring the pattern automatically. That pattern we can follow it for forthcoming students. It is possible, but none of the institution will do. Of course, pattern mining, nobody will do. So that is historical data. Past 4 years data, if we analyze, that is history. Now for the present batch, we can take decision recommendations. That's it. Now, predictive tools such as machine learning methods, integrity factors, visual aspect, colorization, how it is different way of color, sound, wear, these all of the way we are trying to find out the fault. This is a possible way of finding fault. That's an embedded system. What is embedded system? It is integral part of collecting sensors data from machinery, from any kind of a solar, lot of huge solar panel we may install. Then how each and every panel is functioning. We cannot periodically go and check with tester, positive, negative, yes, light is coming, solar is working. We cannot do like that. So something automated. Whenever we are going for solar energy with large, huge amount of panels when we install, then we may need to maintain. So that fault maintenance we may need to automate. So now embedded system, there it is required. In the large gallery of solar system, we may need to bring one device and we may need to keep on sensor. Then periodically it has to sense, or at least daily basis it has to sense, or some morning one time, evening one time. That all we may need to control. We may need to set when it has to start analyzing, when it has to keep quiet. That's all. 24 hours we cannot sit and analyze. So that all. Some crucial part we may need to do 24 hours. Solar part not required. So morning one time, evening one time only we can check. That's more than sufficient. So like that embedded system we need to do again. Same machine learning algorithm what we discussed like yesterday. Today different algorithms I'm introducing, different data set I'm introducing. That algorithm again we need to prune, or we need to bring miniature model or student model, or we need to bring compressed model, or pruning, or quantization, reducing the quantization, or knowledge distillation, any of the method whatever we discussed. Again we need to apply the same technique. That what we have done, that we may need to fit into the device. That device periodically ask for the data from the sensors or deduct the data from the sensors. Then it starts taking decision based on the model or the logic which is given, and based on the monumental data, historical data, then it will be start doing it. Now, embedded system we cannot train. So weights and the miniature model we will be giving. Based on the training phase weights, based on the miniature model, the test data it will be started predicting. That's all. That is called embedded system. Now AI technique, what are all the way? 3 popular algorithm only available: machine learning, deep learning, reinforcement learning. Within machine learning and deep learning, these two are major: supervised learning, unsupervised learning, common to both machine learning and deep learning. But number of algorithms are different. The intensity and the mathematics will be different. That's all. So again, another section is there within machine learning also, within deep learning also. That is time series model. Based on time, wherever we are working, that is time series model. The best example for time series model is electrical grid. If you look at electrical grid, are you anyone aware of energy trading? This is one of the popular area, energy trading. Energy trading. Have you heard of it? We all do trading for investing money and this stock market, ICICI Bank share purchase, like that, right? Similarly, energy trading is there. You check on the internet. You can purchase energy. You can sell energy. You can generate energy. You can install, what to say, your solar panel or something. That solar panel, you can generate a lot of electricity. That electricity, either you can sell it to the government or you can sell it to the energy trading center. So you can again invest, you can make money, you can predict when the energy point value share will be going high, and this energy trading you can try. So a lot of platforms in abroad, it is becoming popular. I'm not sure about in India. I have not heard also. Introduction to energy trading platform is there. Wait a minute. Energy trading platforms. There are a lot of platforms available. India available, it seems. So India, one platform is there. Forgot. IEX, Indian Energy Exchange. This is one of the platform. IEX only I was searching. I have forgotten. So this kind of thing we can try doing. When in this electrical grid, what are all the way? Just it is deviated topic, energy trading and a deviated topic. What I am trying to tell in terms of machine learning is energy grid, short term and long term and block prediction. I have published plenty of paper in this direction. More than 4 papers I am having in the energy sector. Short-term prediction means next 1 week, next 1 month, how much electricity is expected to be consumed in the region of JNTU, Kukatpalli or Tirupati, how it is going to be consumed in the Tirupati region. Especially Tirupati region, it is entirely different, right? Seasonal means all of the lodges will be full, people will be more crowded, and temple will be decorated. So energy requirement will be vary. So short-term prediction, they need to predict periodically. Every area there are a lot of challenges, not only Tirupati. Long-term prediction, monthly prediction, quarterly prediction, how much electricity is required. That every energy sector need to predict. Block prediction, every 15 minutes once, what is electricity required. See, for example, early morning 3 o'clock, the consumption of electricity will be more or less lesser. In a family, one fan or one cooler, one heater, this much only we will be operating. But once the time goes to 9 o'clock, 10 o'clock, all the corporates, all the organization, all the institutions are running, then the energy requirement will be entirely vary. You cannot hold a lot of energy also. You cannot drain your battery also. It will be completely disaster. Energy sector is life or death. One frequency is altered and little voltage level is increased, little reduced, all will create some problem that you know better than me. I don't know anything except fundamentals. So block prediction, these all how it is possible. It is possible nowadays with the AI. So this AI is possible to do. So in this is the best example I can make you to understand through your own field. Most of you will be either electrical or electronics. This is example for time series analysis. Based on the time only, you can suggest February month, historically how much it is consumed. That will be the indicator for this 2025 February month. Historically, January, how it is consumed. That are at least last 3 years, last 5 years. That is what. So it is time series. Time is always playing a pivotal role. 8 o'clock. What is the consumption of electricity in the zone, pin code 114, pin code 214, whatever you call, or Tirupati. So that is called time series analysis. So within machine learning and deep learning, we have time series analysis. Again, two sections, machine learning time series and deep learning time series. This recurrent neural network is one such time series analysis. It is coming under deep learning. Machine learning time series analysis are a little different. So these are all some of the way algorithms are helping. All of the algorithms, how it is helping. Bits and pieces you can start learning, then you can learn formally AI from the beginning or scratch. So these are major division or categorization of AI. Yesterday I could not tell these all, so today I'm telling. How AI based predictive maintenance, not only predictive maintenance, any department, the same story. That is the beauty of AI. So data collection, first you need to collect data, then data pre-processing, cleaning the data, missing data you need to, now this data pre-processing hands-on I will be demonstrating maybe in 10 minutes. So or 15 minutes, data pre-processing, feature extraction. Sometime all of the data point we cannot keep. Data point means column. All of the column we cannot maintain. We may need to extract the feature. Sometimes the data may be image, data may be video. So we may need to extract features out of it. Essential features or transformed features or what to say. Another thing is called dimensionality reduction. So that dimensionality reduction through features, there are several techniques. Feature extraction is again, we need to spend at least 1 week. Every title we need to spend 10 hours 1 week for understanding as a beginner. Later on, something we know, where we don't know, that only we will learn. Where we don't know, that only we will learn. That's all. So feature extraction. Next, once feature means column. Whatever the column we are passing it for the machine to learn. For example, students' data. Gender is a feature. Their mode of accommodation, hostler, day scholar is one feature. Then their category admission, whether payment quota or counseling quota, that is one feature. Then second one, or sports quota, something will be there, right? Then another one, 40-50 subjects marks. Every subject is said to be a feature. Marks of every subject is a feature. That's all. These are all features. When it is image, see, just if you look at my image or anyone's image, it has a feature. Every column, it is a row and column manner. Pixels are constituted row and column manner. So that row and column, it is that column is said to be a feature. That's it. Once the data is ready, data is first we may need to make the data to become suitable for the model or suitable for the machine learning training. So that making data readiness is very, very crucial part. That part is said to be art. Until then, artistic. How much we know statistics, how much we understand data distribution, probability distribution, how we need to clean, which technique when we need to apply, how to find out linearity, non-linearity, that all, this data collection, data pre-processing, data extraction, these all art. No one can teach. We can learn, but how to do, no one can teach. Every problem statement, every data, it will keep varying. So these all said, in my opinion, I'm calling, no textbook, nothing will give, this all my nomenclature. This is artistic in nature. Although science is there, how to configure, how to bring, that is artistic in nature. For example, in your department, for example, you are doing a project. So how you are arranging all of the sensor, which sensor you are purchasing, which hardware you are purchasing, how you are giving connection, how elegant and compact you are making, it is art again. Science is there, but no one can sit and tell you, you need to buy this kind of breadboard, this kind of sensor, this kind of hardware for every application. Nobody will give the timetable or a kind of table or manual. So we need to apply our strategy for every application. So now after that, it is science purely, model training and deployment. This is only yesterday I have explained deep learning. I didn't explain the rest of the thing. I didn't do data cleaning. I didn't do data pre-processing. Ready-made, perfect, minisced data started using. So no artistic, directly scientific method. So that when I explain also the same, someone else explain also the same, concept is same. The way of explanation will vary, that is different. So model training and deployment. Yesterday we have seen convolutional neural network deep learning model. That model, how to configure, how to understand, it will be universally common. Now this is science. Next, prediction and alerts. We need to predict the result, or we need to interpret the result for the prediction and alerts. Every machine learning model will give some number. That number, what it is, how we need to take into that context, agricultural context, business context, energy context, and predictive maintenance context. Every context, how we need to interpret, that matters a lot. That's all. So this way, if you go, reducing unplanned downtime, that's it. So what is again the same masala? Embedded means resource constraint, data volume and variety. Different data will be generated by the sensors. The volume of data will be challenging. Then model accuracy and interpretability. So now every model, how much accuracy it is giving, how we may need to interpret. So that is a matter. So these are all the challenges. Now, what are all the future solutions and optimization? Edge AI, edge itself can be said as embedded, that's all. Then quantization, pruning, TinyML. Yesterday we have seen quantization is the technique, 32-bit data it will generate during the machine learning training. What is 32-bit? For example, multiplying 224 with 0.00789110. So 224 into this much biggest number, if you multiply, it will become biggest number, it will occupy 32-bit. So that we may need to moderate, and we may need to apply several quantization techniques available. We may need to bring the higher precision to the lower precision, maintaining the relativity. Whenever we are bringing down, we should not deteriorate the hidden meaning of the data. Then the reduced data point, lower precision data point should be accommodated in 8-bit or 16-bit. That's all. Maximum embedded device may work up to 32-bit maximum, or else 8-bit to 16-bit version whenever we are using. That is what embedded system. Quantization, pruning, already I said, very lower weight, 0.000. There is nothing, it will be inferred. What is weight is, yesterday I have shown one demonstration. In the intermediate stage, the cup, that coffee cup, it will be very shadow area, except that coffee cup area, rest all will be shadow. Those are all the weights are said to be lower precision or lower weight that can be pruned, removed. So whenever between one neuron to the another neuron of the next layer, the weight value is becoming lesser, that connection can be disconnected. Only then the miniature model we can do. That is pruning. TinyML, that is what we have seen. Low power devices, whenever we are using the machine learning, that is TinyML. Then application, manufacturing sector, energy sector, transportation sector, and smart cities. So nowadays, what is a smart city is becoming the highest booming area. In India, Hyderabad is declared as one of the smart city. There are 2-3 hubs declared as a smart city in India in the global level indexing. So global level indexing, I have seen one Switzerland, I guess Switzerland, yeah, one of the city is the #1 smart city of the world. So I feel like to visit once. So I have decided to visit. You can see that then all of the sensor predictive maintenance smart city #1 in the world. I have maintained the data point and all. I am having, yeah, Zurich, Switzerland. Zurich. That is the number one. So after reading this, I handled big data analytics in smart cities, one Atal workshop. So by the time only I understood Zurich. That handled exactly 30 days before. Hyderabad only physically I visited. So that 30 days only I'm carrying this desire. I need to visit Zurich. Switzerland is the best place to visit for picnic also. So then without this all, whatever we are studying in terms of theory in this workshop, everything they need to apply. Your entire workshop material, whatever the title is coined, wonderful title. But that all we are discussing here, that all practically advanced level, optimized level, efficient level, they will be implementing. Only then they will be ranked as smart city 1. Now, Hyderabad is aiming to become India's #1 smart city. Their ambition, it seems. Government is having that ambition, it seems. So benefits, reduced downtime, cost savings, this all, etc. You can read that's all. Future direction, integrating with IoT, autonomous maintenance. No human intervention at all. Automatically, it has to maintain self-maintenance, prediction, corrective action. This autonomous maintenance, people are bringing in 6G technology. 6G, it is naturally, people are working on it. 20, 30, 35, 6G will be completely, becoming, ruling the world. That has autonomous maintenance. Everywhere they are trying for autonomous. 6G is the architecture or communication technology from top to bottom dominated by AI. Every tiny corner of 6G is ruled by AI. So after 6G, it is my prediction, there is no 7G. Quantum communication, quantum computing, quantum entanglement, quantum, or there are, you read highest exciting. Sometimes when we read, I feel afraid because that is a different planet altogether. So that all of the communication is going to happen. That nothing I know how it works. 6G is based on AI, so that I am discussing about it. So there is no 7G. Historically, I am maintaining one session. 1G, 2G, 3G, 4G, 5G, 6G, I used to address in one of the workshop. In that case, AI is played a predominant role in the first level of data, delivery to the receiving side of, sender and receiver side. So completely in the entire journey, AI plays a role. So their autonomous maintenance they are bringing. As of now, there is no other field people are trying autonomous maintenance to the fullest. Then explainable AI, that is highest. It is also saturated. It is not a new topic. It is about to saturate, or within couple of years, completely it will be saturated. What is the meaning of explainable AI is, AI is working. Yesterday, I have demonstrated deep learning. And I have proved in front of you, the accuracy is 99.2, right? That is not a matter. How it is reliable, how it is predicting. Internally, I need to dig out how CNN is learning all of the intermittent result, intermittent stages. I must able to interpret how it is working on different data, how it will work. What is the way the mathematics is happening in every stage. Everything I need to explain. That trustworthy of the model, transparency of the model, accountability of the model, understandability of the model, explainability of the model. These all of the factor when we bring, that AI model is said to be explainable AI. This is not only for particular sector, industrial automation, energy sector, and medical sector. Everywhere they are expecting, transportation sector, because people need to understand. Simply telling my AI model is 99, when practically deploying, sometimes it is bringing disaster, sometimes it is failing. Business means life or death, again money involved, right? Overnight multi-crore is lost, means that guy need to attempt suicide only, nothing more can be done. Electricity, electrical grid, something goes wrong, then that electrical disaster people need to bear. So everywhere it is matter. Health sector, that one patient only will be dying, rest of the sector multiple way people will die. Business sector, that one person owner only will die. The next, this all. So that is why people stopped trusting AI. These all 5 factor, whatever I said, I cannot even repeat it again. That transparency, these all in your flow, it will come. That all are said to be explainable AI. Now, anomaly detection, data collection, adjustment of the parameters, baseline creation, boundary. If the sensor value is between this range, then that all normal. Less than that, above that, it goes something abnormal. Less than that means different fault. Above that means different fault. Where no value means totally out, that sensor is out, right? So that all we need to teach to the model, baseline creation, then anomaly detection. During anomaly detection, image anomaly, it is easily then deep learning, signal anomaly, pattern recognition, we can apply this all. Now, predominantly in the anomaly detection, one class problem, one class detection only will happen. What is machine learning? It has to be balanced data. What is balanced data? I will give you one example. Suppose one of the cancer hospital, any cancer hospital you can imagine. Everyone, those who are facing tumor in any part of the body, they will be afraid of it. They may be suspicious. They will go for tumor testing in the hospital, right? So out of 3,000 patients in a year, let us imagine. So 1,000 or at least 1,000 patients are really detected with, diagnosed with cancer. 2,000 patients are diagnosed with not a cancer. This is also balanced. 2,000, 1,000. That means almost 75% not a cancer. We must thank God, right? Then 25% or 30% are cancer. That is also balanced. Imbalanced data, I will tell you that it is not even imbalanced. One class, I will tell you that what is imbalanced data. Balanced data, imbalanced data, one class data. What is imbalanced data? Credit card fraudulent. Just imagine this field, credit card fraudulent. Just 5% only happening across India, across the world. That itself we are not able to bear. Lot of laws, lot of Indian Cyber Crime Bureau is sitting and crying. They are not able to handle the cases. They are not able to read. You read that article. How many cybercrime attack is happening in India? How many cases are filed? How many are they able to pay attention? So they are creating lot of cybercrime warriors or personals. You can read all the Indian government article. In government of India themselves declared only I'm talking. So a lot of problem we are facing. So when the credit card transaction I am taking, the history, 95% safe transaction, 5% only fraudulent transaction. Now data become imbalance. In machine learning and deep learning, this is another under supervised learning, another arena. In this arena, we may need to work on imbalanced data set. Even in the cancer, it may happen. Luckily, imagine in Hyderabad, 3,000 members are going for tumor diagnosis. 2,800 members are not diagnosed with the cancer. Only 200 members are cancer. Happy, thank God. But machine learning model, deep learning model will suffer because the data is imbalanced. So in this imbalance, it is separate research arena. Again, 1 week we need to talk about the workshop. Imbalanced machine learning, deep learning, imbalanced deep learning imbalance, and machine learning imbalance, deep learning imbalance. We may need to talk for 1 week. Only then adequate knowledge we will get, either workshop or independently learning. Now, what is one class? Sensor will fail. It will work for 3 years perfectly. All of a sudden, one day only it will give wrong data. Then you will have complete one class only. Only one data point you will have wrong data. So that is called one class data. So how we may need to handle that one class data? For that separate algorithm. This I have learned because of your workshop. Until this material, I was not aware what is one class problem. Because of this workshop. Every workshop, something I will be learning, something what I learned I will be delivering. That's it. So why one class? Lack of anomalous data. So in any corporate, any sector, people will be buying a best sensor, best hardware, then they will be deploying. Why the anomaly comes from the day one? Maybe coming after 40 days or after 40 years, 10 years, right? So lack of anomalous data. Even credit card fraudulent, although it is imbalance, that 5% data we are having. Next, imbalanced data set. Either one class or imbalanced data set we will be facing in the anomaly. You may able to feel what is imbalance, what is one class I'm talking about. So every hardware, day by day, it will not be a failure. Rarely it will become failure. Once if it is failure, totally shut down, right? Then that class will be very minimal. What will happen? Machine learning, it will pay attention to learn one class which is dominating. It will not bother the attention of the low class. See, even in a class, in your teaching class, imagine only 10 students are not studying well. You are having 80 students, 70 students are topper, 90 above, 80 above, 70 above. You don't even bother. You live in the hill. I am going to produce pass percentage 80%, 90%. My university is asking only 70% pass percentage. Okay, I am 90% of producing. Let them live in the hell, you will think, right? That the same machine learning also will do. So the highest member, then you cannot proudly tell I got 90% accuracy, right? Similarly, your class is bright student, only 10 are dull. You cannot proudly tell because of me 90% accuracy I produced. You cannot tell, right? So you may need to handle it differently with a different strategy. The normal machine learning algorithm, we cannot apply to imbalance. So next is, what to say? Wait, I myself am not able to read. Prevalence of normal event, that font I am not able to read. Prevalence of normal event. So normal event only always will be there. In the case of predictive maintenance, rarity of abnormal event, very rare. Abnormal event in a year, fault maintenance, faulty thing happening in the smart grid. See, maximum per month 3 to 5 times power failure I am facing. Summer time quite often, that is shortage of power. Rest of the day, power failure per month, 1 hour, 5 hours only I am facing. If periodically something fault, what will happen? That entire month, no power, I need to live. I need to go to once upon a time, long ago, that life culture I need to go. Rarity. Because of this, one class classification. So what are all the common techniques exist in machine learning or statistical method? What it is statistical method. Gaussian model. What is Gaussian model? So that is probability distribution. How the data is distributed by that sensor. So that distribution we can see, visual plot, just distribution, how it is that data is there, rhythmic there, or fluctuation is there, or suddenly high spike, completely irrelevant data is there. That way we can look at. Next is Z-score, already I said. So that is x minus mu divided by sigma. That's all. Mean divided by standard deviation. So identify data points that fall far from the mean. So which are all away from the mean. That is possible to deduct, that is Z-score. Then distance-based approach. That is k-near. Euclidean distance you would have studied. Hamming distance, Euclidean distance. Square root of the distance between 2 points, x1, y1 and x2, y2. In your childhood days, 9th standard, 8th standard, you would have solved that problem. x1 minus x2 the whole square plus y1 minus y2 the whole square, the square root. That is Euclidean distance. So finding the distance between the points, it is possible to apply the machine learning, then identify how many points are away from the normal closed circle, then which is away from that closeness. That way we can find out the fault. That is KNN, that is also machine learning. The next is, you may able to visualize, someone wants feedback, it seems. You give them feedback, they will sleep then. See, for example, this KNN. Between two different points, the distance is very low, then we will be getting very close points. So all the points will be closer. It will form a thick cluster ball or elliptical like that. So if the distance is too high, the point will be away from it. Then that seems regularly whatever I'm getting, if I find all are becoming close to each other, suddenly some points are not fitting into the distance at all or closeness at all, then it will be far away. That is a meaning, or that is the way the anomaly or faulty points, faulty sensor, faulty hardware can be detected. Now these are said to be faulty because the rest all fitting in that one single range. That's all. So this method of doing is said to be, what to say, KNN, K-nearest. This is one of the popular algorithm in machine learning, KNN classification, KNN regression. So this, it has a lot of distance formula. This is popular formula, Euclidean distance. Any point, x1 minus x2 the whole square, only one parameter if you have, only this. If you have one more parameter only, we need to go for. This formula is stopped, that's all. If one more parameter is there, y1 minus y2. One more parameter is there, z1, z2. How many points we are having between two different points, how we are calculating the differences, accordingly we can go ahead. 1 minute, it is not clearing. Okay. Done. The next one is one class support vector machine. That is different algorithm. Isolation forest. That is different algorithm. Autoencoder, deep learning. This is machine learning. This is machine learning. This is deep learning technique, autoencoder. Again, variational autoencoder, GAN-based method. These are all the exhaustive methods we can apply for predictive maintenance. So many other methods also available. Something I'm giving. That's all. Advantage of one class, disadvantage applications, done. Now theory is over. Let us move on to hands-on. The data set which I am using is pump data set. Something kind of sensor data. That data I have uploaded. Here it is available. 50 sensors, 2,25,000 observation rows. It is brought. It is almost, I can say, big data, not a normal data. Big data with machine learning, that only. But PySpark we should use. That I am not bringing. Machine learning only, what to say, normal machine learning only I am bringing. This is the data point we are going to discuss. In this, it's completely working. No, there is no problem at all. So this material, but I cannot execute it because to upload the data itself, it is taking 28 minutes. Every time I tried 20 to 35 minutes it is taking. Average I have taken 28 minutes. So 3 times I have executed for this session. So it is taken half an hour. So now, before going to machine learning, first technique what I am giving is unsupervised learning, isolation forest technique. This is the technique we are going to discuss. What is isolation forest? This is the one of the popular technique. Most of the people are using it for anomaly detection or fault finding or fault diagnosis. That name of the algorithm is, that's all, isolated forest. Don't ask anything. This is a ready-made algorithm. That's it. It is said to be unsupervised. What is unsupervised? There is no label. What is no label? For example, 140 members were attending when I joined. Out of 140 members, I don't know about your temperament, whether you are good teacher, bad teacher, intellectual teacher, nothing I know. That is unsupervised. Suppose I'm conducting 10 tests for you. Then I will take all of the data. I have rich data. I can easily analyze, I can label you. So labeling means every person, yes, intelligent person, average intelligence, poor intelligence, excellent intelligence, I need to label it. That all of your detail I can have, your name, designation, institution, department, years of experience, your salary, anything I can have, but I must label you this. Or I don't have these all. Your 10 mark I am having. These, for these 10 marks, what is the label I'm giving? That is called labeled data. Whenever we are having labeled data, that is supervised learning. This is unsupervised learning. So how it is working? Python code. Simple we are understanding. With a little numerical also I will explain. Then the large, the 2 lakh data, how I can explain? How it is working, I cannot explain to you. So now import NumPy. This NumPy is said to be all of the numerical linear algebra, matrix algebra. These are all the mathematical operations. Highly, we are in need of machine learning. So all of those operations are available, vested with the power of NumPy. That's all. Whenever we want to apply some small mathematical operations, we need to have NumPy. So not only for mathematical, this NumPy has array creation. It will help us to create array. You may be knowing array by this time, at least one programming language you would have studied. So as NP, if not MATLAB, you may be knowing. As NP, this is Alice name. As NP is Alice name. What is Alice name is, I may have nickname, right? That is, yeah, instead of NP, you can use anything, donkey, monkey, yen, anything you can use. That is Alice name. Why Alice name people have brought is, NumPy has 5 letters. They cannot type, it seems. So they wanted some short name. That's why people have brought NumPy Alice name. That's all. Now, another one we are bringing. This is one way of bringing the package from the secondary memory to the primary memory. There is another way from within the package, which module we want. sklearn, scikit-learn. This is a superhero of machine learning. Today only we are discussing machine learning, not deep learning. That I don't know how to teach also. I have not done this much, only I can understand and I can explain. sklearn.ensemble. Ensemble technique means multiple algorithms will work sequentially or in parallel in order to take prediction. That is said to be ensemble model. So sklearn is only package available for machine learning in Python. That's all. Anything you do in machine learning, you need to depend on only sklearn, scikit-learn. Then imagine how much bulky it is. You cannot bring everything to here, right? So if you are going to hostel, you cannot take your entire house to hostel. You will take what is required for your life only. You will take from home and you go and live in the hostel, right? It is like that. So ensemble, sklearn, within that we are asking for ensemble, requesting for ensemble. Within ensemble, what model we want? Isolation forest. So 3 level we are telling. Whereas here only 1 level, entire NP you bring, whatever I want to do, I will do. That's all, because that is small package. Whereas this sklearn is superpower. So within the sklearn, we are demanding for ensemble. Within ensemble, we are demanding for isolation forest. Ensemble algorithm itself available these many. So that we wanted to bring this. For that, this syntax. From this, import this. That is the meaning. Now, we are using NP array, some random data point. I was playing around. What is it? I will tell you. This data, simply I was feeding. What is this data? It has some logic that I will tell you later. These all of the data, I am making like a ziploc. So that I am making it as an array, np.array data. Now what I am doing? Isolation forest, I am applying. Contamination equal to 0.2%. So what is the meaning is, contamination means the faulty information in my data is only 2%. Then random state is 42. What is random state? It is applicable for all of the machine learning algorithm. You must learn what is random state. Whenever we are supplying data, 2 lakhs data, 4 lakhs data, 5 lakhs data, 1000 data also, let us imagine. So for train, test, split, or all of the activity, it will not take the first 20, first 100 and all. It will pull out the random record. When it is pulling out the random record, every time we are forcing the machine to pull the same record. Otherwise, it will change random record. Then your accuracy will be changing. For example, I want to use on pre-processing technique. If the same data point is retained, only then how it is differing with the new pre-processing technique, hyperparameter tuning, how it is behaving, I can able to understand, I can able to write a research paper. Otherwise, not possible. What data point it is taking, I don't know, you don't know. So that random state equal to 12, 42. Anything you can keep. You can ask me question, why 42? Yeah, I can keep 2 also. If I keep 42, different set of random records are constituted. If I keep 2, different set. Every number will lead to different combinations. Suppose out of this crowd, I am calling randomly 2 male faculty, 2 female faculty. Then tomorrow also I'm calling the same. That means randomly only I'm calling. It happens to have this. See, for example, I'm having log, one box full of your name. I am drawing randomly. In that random, first day 2 female, 2 male faculty name is coming out. Next day, the same may come, may not come. This is called random. But if we keep random underscore state equal to 2, the same people only will be taken for tomorrow. That is the, got it? Randomly I'm picking, that random will be fixed. So that is random state equal to 2. Isolate forest dot fit equal to data. Now the data, what we have created the data point that we are passing. This is called forming the forest. It is going to become a tree. What is the way it will work? I will tell you. Now you can imagine this point, my algorithm randomly reading this 4. This 4 is randomly taken. Oh my God. This 4 is randomly taken. Randomly I'm reading because random, right? So why you are using 4? You cannot, you keep 5 also. I don't bother. So that 4 will be the root node. How it is working? Now, another point it will take a random. 6. 6 is above than this, right? Always 6 will go here. Then 2 will be taken. 2 is less than this. Always it will go here. Then 50. 50 where it will go? It will be above than this. Then 6 and above, it will go to 50. It will be doing like this. A tree will be drawn like this. That's all. Nothing is doing. How the tree is drawn? The logic, there is no logic. Whereas immediate supervised learning, I'm going to explain that also related to the tree and the forest. That's why that I have taken. Their mathematics plays a role. Then I will explain. Here simply it will do greater, lesser only. So in that we are giving the clue contamination is 2%, 0.2% or 2%. Look at the data. 67 is contaminated data, 50 is contaminated data. Rest all close to each other. Then what it does is fitting means always we are binding the model and the data. These two binding, mathematics and the data we are connecting together. That's all. That is called fit. Whenever in the machine learning, deep learning, you are seeing fit. The model is ready. What is model? Mathematics, then data. You are applying. For example, apply the formula, quadratic equation, immediately do. If I say what you will do, give me the point, then I will give 3 data, A, B, C. Then you will be sitting and plugging. That is called fitting. That's all. Now, isolated forest dot predict. We are passing the data for the prediction. So isolated forest decision function data, it is predicting. See, how it will do is, all of the normal data it will give 1, 1. All of the contaminated data it will give -1. That's all. So -1, 1. -1, -1. -1 is said to be anomaly data. +1 is said to be normal data. Then anomaly score, how it is calculated is, it is based on harmonic series and it is based on height of the tree. That all not required leave. That's all. That has 3 formula. Then if I do, session will be over. Now pump sensor data. It is taken. That pump sensor data, I will show it to you. So this is the sensor.csv. I will slightly open and you can see how the data is available. 2,25,000 data. It is not at all allowing to see also. Otherwise, here itself you can see. Wait a minute. May be available. Not at all. Sensor 1, 2, because it all became blank when I reconnected here. Once again executed, these all, that smiley is there, no, that all result, it is reconnected. Leave it, that's all. Now not possible. Sensor data, the data set is given here. You can download and see to it. It is CSV, comma separated view. It is the variant of Excel, that's all, nothing to worry. Now unsupervised learning we are discussing. The same isolation forest, NumPy, PD, sklearn. You may not be able to understand, let me download, because I need to show you something to clean. I need to execute. I don't know what to do because it is taking half an hour for the execution. So let us see. Now I'm executing. It is done. This NumPy pandas. Pandas is for handling the large set of row column manner data. That is what pandas. This only will hold. It is a kind of variable or vessel, we can say. So it is holding. Then again the same sklearn ensemble isolation, matplotlib, pyplot. This all not required. I have removed the plot because it will be bulky. Then next is sklearn metrics. We are going to work in. We are going to work in 1 minute. We are going to work in decision tree classification, isolation forest. Yeah, isolation forest. It will give the report anomaly how many, normal how many, 1 minus 1. For that, we need to bring these all of the components, classification report, confusion matrix. Now, this is the cell. I need to upload the data. I believe that it is downloaded. Now choose a file. See, it is simple code from Google Colab. Import files as F. F means files. Alias name as F. So that F dot upload. I am uploading. Now choose a file. It will be rotating until I give the data. It will be rotating. Download. It is taking this much time to download. 1 minute. I did it right. Download. Yeah, it didn't work. Download anyway. Oh, no problem. Oh, that because of that I didn't click. It is disappeared. Why? It has to download, right? What is its botheration? It is not at all downloading. It is taking this much time. Oh my God. All right, we need to click and upload. See, otherwise I will upload some other Excel data, and not for this purpose. See, this is internal marks. So some marks I will do this Excel sheet. That's all. Uploaded. See, 0%, 100%. This is so we need to upload that data also. Where it will be available? This folder temporarily available. Once if I close this notebook, it will be gone. See, sensor.csv it is available. Yeah, sensor.csv is available. It is brought. This also brought. I am removing, deleting the file. Then I am closing. So it is done. Whether I have read or not, it is available. After that, see sensor.csv. It will be ready. Yeah, it is working. My sensor data, somehow it has come to that folder. That folder path is right means it will execute. Yeah, executed. Done. See, it's unnamed 0123. Then timestamp. You can treat this as time series data also. I'm not doing time series. Then I'm doing one unsupervised, one supervised. Now I am discussing about unsupervised. Sensor 1, 50 different sensors it is having. Out of 50 different sensors, some of the sensors are not having values. One of the sensor totally failed. See, this sensor 8, some data points are missing. Sensor 15 totally failed. So this is just to see the data, feeling, data.head. Whenever we give data.head, 10 records it will show. That's all. Now data.describe. So it will be describing about the complete minimum value, maximum value. It is kind of 8 component report. 25% quartile, 50% quartile. These are simple statistics. We need to come with the formula and discuss, no time. So 75% quartile, standard deviation, mean, and count how many data are available. Then minimum value, maximum value of every column it will give. This is called description. For every column it is providing. Next, data shape. How much data I'm having, rows and column. If you look at 2,20,320 data, 55 columns, rows and columns. That's why I said it is a big data, very bulky. Then what I am doing, timestamp I don't want because I am not doing time series analysis. So data, what is data again and again? Look at here. What I am reading, this I am keeping it in data. That's all. That is my variable. That data only having data. That's it. So you can have anything also. So data.describe, data.shape, data.info. It will give information about every data point. See, the first data unnamed is integer. Rest of the data are float. All are numerical only, float. Because sensor data normally it will be in number only, so that it is float. So totally I'm having 51 floating point data, 1 categorical data, 1 object means categorical, 1 integer data. What is object? Look at machine status. It is having 3 recovering and normal and abnormal something. These 3 data only. The 2 lakhs data are having these 3 combination, in which normal is heavy and recovering is minimal, 1%, 2%, and another one is not available, or what to say, normal, abnormal, not a normal. So that data is also minimal. So this is why this status is available. It is labeled, although it is labeled, I will be removing for the training. That is why it is unsupervised learning. Now next we are going for machine value count. See, normal, I said no 1%. Broken is only 7 data, only 7 day count available, broken. Then recovering is minimal, very 2%, 1% only. So normal is 2 lakhs data, 2,58,000 data is normal. Then it is said to be highly imbalanced. It is not one class, it is highly imbalanced. So next, now what I am doing, instead of count, I am looking at the percentage. For the percentage, the same syntax. This is so we need to give the name of the column, single quotation or double quotation. Exactly, we need to copy paste the name of the column which is given in the data sheet. So data of data frame, data, square bracket, name of the column, dot value counts. So we need to counting, we are counting, whereas the same count normalizing. Normalizing means total record how many divided by, normal record how many divided by total record. That's all. That is normalization. How many female in this session divided by the total participants. How many male in this session divided by total participants. That is normalized data. So I can understand percentage of female participation, percentage of male participation. That way it is 93%, 0.6%, 0.06%, 0.000032 because 7. So next is null sum. Is there any missing data available in every sensor? Yeah. See, sensor number 0, it is not sensor. It is not sensor. First sensor itself 10,000 data is missing. Second sensor, no, a 0 sensor. First sensor 369. Second sensor 19. Then one of the sensor 15 sensor, entire 22 is missing. Then if entire sensor data is missing, I need to throw the column. So now cleaning is highly required. So this is not available how I am handling. And one entire column is not available how I am handling. I don't want timestamp how I am handling. Unnamed column is there. How I am handling. How I am going to handle that machine status. Machine status, nothing is missing. So how I am going to handle that? So that is the pre-processing data cleaning. Now whatever we are doing is data exploratory. We are understanding different perspectives about the data. Now total missing value, data dot isNull dot sum. Totally 3,44,000 records are missing in the entire data point. So how to handle the missing value? That is again biggest science. Minimum 500 techniques available. Handling missing value. Usually popular drop NA, that row delete, that column delete. That is one method. Because I have 2.5 lakhs data. Wherever it is missing, that row I can delete, that column I can delete. That is one method. Or else data dot fill NA method equal to forward fill. Forward fill means what is the next person data, copy paste. For example, my mark I am not ready to give it to you. Or my salary I don't want to give it to you. You are asking me my salary. I don't want to tell you. What you can do? You can copy my previous person data or next person data. If you copy my previous person salary, that is backward filling. If you copy my next person salary in the order of name list, that is forward filling. So if it is available, if that is not available, that will refer its forward. Somehow it will get the data. So that is very, very, very unscientific, rudimentary. Somehow we want to maintain the data for the model because MT cannot be recognized by any of the formula. So that cannot be computed by the computer also. So that forward filling, backward filling we are doing. Lot of techniques, random forest we can use for missing value computation. Several techniques available. Machine learning, scientifically we can do. Another scientific is mean mode median. If the data is normally distributed, bell curve, normal distribution, you may be knowing. If not, I will show you. This is the normal distribution. This assumption is made for entire statistics. Most of the statistical formula is designed to keeping in mind about the normal distribution. This is what normal distribution. This is what every class you will have. This is the best way always you can remember. In any college, even if you go to IIT, this normal distribution will be there. 10% of the students excellently performing, 10% of the student seriously underperformance, rest all average, little difference, 60%, 70%, 80%, like that small difference people will be there. This is called normal distribution. If you take age of the apartment, 10% are newborn baby, kids, 1 year baby, 10 months baby, like that. Then 10% are elderly people, senior citizen. Rest all average, 30 year, 40 year, 45 year, 50 year, like that. This is normal. Most of the natural phenomena will follow normal distribution. That's it. So that, where we miss it. Yeah. If the data, missing data we need to remove. All of the other data is normally distributed. We need to use mean. That is for numerical, this mean imputation. This technique is said to be imputation. This is entirely whenever the data is missing, when we are trying to fill that, then it is said to be, technical word is said to be imputation. Mean imputation, then mode imputation. Gender is missing. 20 participants don't want to give their gender. Then how can I fill? So what is the majority gender, male or more? It doesn't matter, everywhere I will fill male. That is called mode. Median, when we need to fill is, if the data is not normally distributed, we need to fill median. That's it. So categorical is missing mode, numerical is missing mean or median. If the rest of the data is normally distributed, mean. If the rest of the data is not normally distributed, median. That's all. So next is, I am using fill, forward fill. So that's it. Now data Y. I am removing that machine status categorical column. I'm removing. I'm taking that in a copy called Y. Xerox copy I'm taking. That one column alone. This is the column. Normal, repaired, failure, recovering. That is broken, recovering. That column alone, I'm taking it out. Then next, what I am doing, label encoding. I'm doing label encoding. Now also I can make you to see Y dot head. What is label is, all of the normal need to be replaced by one value, numerical value, categorical value, because English machine cannot able to understand. All of the broken need to be given in different. For example, female, male, other gender. 3 genders are participating. Then female number 1 label, male number 2 label, other gender number 3 label. It is called label encoding. So that we are doing. See, look at here. What is happening? Y dot head. The same only I did. Y dot head. Okay. After transformation, it is not data frame. It is not possible to display. If I display Y, then 2 lakhs record. I don't want to take risk now. So Y is now not data frame. It is transformed categorical value. So it is not possible to display. So for that, sklearn pre-processing label encoder. Label encoder we are creating, encode one variable. We are fitting the data Y to encode fit transform. That's all. So we are using, this is the object we are creating, label encoder, encode dot fit transform of Y. That's it. The original data frame Y we are doing. What it will do, that's all. I said no, female, male, and other gender. Anything you can take, for example, EC department, CSC department, EEE department, these three department only participating. CSC department, I can label by 1. EC department, I can label by 2. You don't ask me why CSC 1. You can label anything. All are equal meaning only. ECE, CSC and EEE I am telling, right? How I am telling? Some order I need to call. Somehow I need to call. Or EEE, CSC, ECE. I can call 1, 2, 3. That means 3 different department members are participating here. Similarly, here 3 different data: normal data, broken data, another one you have what, recovering data. That all of the data. Now we are doing, after that I am deleting that entire data drop machine status axis equal to 1 means column in place equal to permanently remove, because I have taken a Xerox copy in Y. That taken Xerox copy Y also I have transformed with label. So now I don't want. Other than machine status, rest all of the column is there. No, that is called as X. That's it. Now we are going to apply isolation forest. Now look at here. Scalar fit transform. I need to give here X, I guess, because we have changed it to X. After removal of the data, the remaining is available in X. That X we need to pass. Rest all correct. Why? It is giving some error. Okay, let me give data. So now, okay, another 10 minutes we have data. So now scalar dot fit transform data. That X will be useful. Where, what is the problem happening? X data dot drop. Where it is going mistake? This is right. Not found, already deleted. Okay, not a problem. Already deleted. One time deleted, again and again we execute. No, it will create error. Now we are executing this. It is also ending up with error. Why? It was not having error. Float could not convert string to float. Where is the string? Isolation forest. No string generated earlier. Data. Fit transform standard scalar. Then I need to give X only. X only. It was working well. So it will give report, complete report -1, 1 it will give. Then model 2. Okay, then I will fix this model. I will fix this error, nothing to worry. Now let us move on to model 2. This is decision tree. For this theory and mathematics, we may need to bring it. Only then we can able to understand. Otherwise, directly coding means, yes, it is possible. That also. Now we are going with the NP Panda. Now we are going for feature selection method. Here feature selection we are using chi-square method. Then we are splitting training data. All of the data. X means independent, Y means dependent. That machine status is dependent on all of the sensor reading value. So that we need to split. Then this is not required. Seaborn is not required. Now we are stepping into sklearn dot matrix. We need to know accuracy, precision, recall, confusion matrix. What is it? Again, theory. Minimum half an hour we need to discuss minimum. So now we are going for all of the columns. We are applying min-max normalization. Somewhere it is going wrong. Data. Data. One line is something I excessively have executed. It is going wrong. What is min-max normalization? You can see the formula. Min-max. Why we need to do min-max normalization? Min-max normalization. This is a formula. X minus X min divided by X max minus X min. In a class, it is possible to apply. All of the mark we need to normalize because it will be highly different. For example, all of our salary, if I put, lot of deviation will be there. There will be a junior faculty may be drawing 20,000 also. There will be a senior professor maybe drawing about 2 lakhs also. Lot of deviation will be there. So that machine will take more attention to the highest number. So rest of the number will be given least preference. So that we need to normalize. So apply log for all of your salary. You try 2 lakhs rupees take salary. 20,000 rupees take salary, 40,000 rupees take salary. It will be nearby value. Log transformation is one method called normalization, and min-max transformation is called another method of normalization. Z-score standardization is another method of normalization. There are several normalization techniques available. So all of the sensor values are numeric. We need to normalize or we need to standardize. So that standardization we are doing, it was working perfectly. One code somewhere wrongly I have inserted or executed. Now using this, see, you can even look at the 25 features I have generated. So using chi-square test, out of 50 features, near 50 features, after deletion maybe 48 features. So we are first top 25 best coefficients we wanted to utilize as a feature. Whichever the column is having highest chi-square value, those all we are selecting. That is K-best. This also I learned because of this session. Until then, we used to do dimensional reduction PCA, or we will be using random forest and highest coefficient where it is coming, that I will be using. These are all the two techniques we will be using: PCA, TSNE, LDA, and okay, I don't know, transcript, then LDA, and we will be using random forest for the prominent feature selection, prominent coefficient finding. So the first time used that chi-square test. So once XFS, these are all the 25 values it started generating. Now we are splitting the data. X of that, out of 25 features, original Y test size is 20% data for testing, 80% data for training, satisfying with respect to Y. So train test split. So X train, X test, Y train, Y test. Yesterday also I have said same kind of splitting, the same set of splitting we need to do. Then we are creating an object, decision tree classifier, model decision tree classifier, X train, Y train. We are fitting the data, training data we are fitting, machine is learning from the data. Then we can test. See, if you look at here, predict X test, we will be hiding the label. X test, X, Y test we will not give. X test will do. It will be predicting in O. That O is compared with original Y test. That is of accuracy, precision, recall, confusion matrix, and report it will generate. That smiley was a complete output. So with that, it is possible to identify how much it is predicting. Then any of the point, all of the 50 for tomorrow, this is 2 lakhs record. Tomorrow I don't have anything to give to training. That will be testing. Tomorrow morning I'm testing that 50 sensor. It will give some value. That if I feed to this model, it will tell whether that data is broken category, recovering category, or normal category. That is called machine learning. Once if I train with this 2000 record, past 1 month record or past 1 year record, I don't know what it is, Kaggle, it is downloaded from the Kaggle. That downloading you need to online sign in, that all need to do. Now I didn't do sign ins, that's why downloaded and I am giving it to you. That's it. So now what we need to do, completely tomorrow data I can feed or automatically embedded device will harvest and give it to this model. Then it will predict whether tomorrow morning 10 o'clock status is recovering, or tomorrow morning 10 o'clock status is normal, or it is broken. It will be labeling and it will give. Not it will give in terms of English. It will give 1, 2, 3. 1 stands for normal, 2 stands for broken, 3 stands for what is the label given in the label encoder. The same label we need to reverse interpretation we need to do. That's it. All right, almost we have reached. I will fix this bug in soon after the session. Is there any questions? All are asking for only feedback, please. Without attending, they will give feedback. What they will give, I cannot understand. Okay. Is there any questions? So let us move for another 5-10 minutes question answer session before closing formally. The material is only one material for yesterday and today, and hands-on also the same notebook, yesterday and today as well. So total 3 algorithms we have seen, deep learning and how to compress using TensorFlow Lite, and isolated forest, unsupervised learning for the anomaly detection. And the second one is decision tree classifier, supervised learning, again for anomaly prediction. That is deduction, this is prediction. That's all we have seen as a sum up. The material is given. What you need to do, you can have file, make a copy on your drive. It will be on your drive, your own copy. You can further edit and add. Similarly, file, make a copy, save a copy in drive. That's all. This notebook will be yours. If you view this notebook right now, you cannot execute. That play button will not come. This play button will not come because you are viewer. When you make a copy on your drive, then it will be enabled. You can execute and modify the code, or you can understand whether it is working or not. That all you can do. That's all. Yes, any question? You can come forward.
Madam, Dr. Harish, madam,
Madam?
I had a small doubt regarding general doubt only, madam.
Yes, sir.
As our deep learning models are predefined like ResNet 151 like that, no, madam. For a research paper that is to propose a new work. So what are the contributions you can do in that networks, madam?
ResNet itself.
And not only ResNet, madam. There are a number of predefined networks.
So what is the way they are expecting is new pre-processing technique or hybridization, two different algorithms, here half, here half. This output we need to feed as an input to that other algorithm. It should be like a pipeline. This is hybridization. Or any new mathematical layer we need to insert in between of any of the existing predefined model, CNN or ResNet, whatever. So one new mathematical layer or fast Fourier transformation layer, something like that. One new mathematical formula we need to find out. That mathematical we need to apply to every neuron as a new layer. Either this one or entirely different way of neuronal structure based on that neural network architecture only. So many Boltzmann network and autoencoder R and LSTM, how people are naming it is how that neuron is arranged and what is the mathematics of that neuron. That only these many flavor, maybe 40 deep learning techniques may be available. So all more than that also, to my knowledge, what I know that I'm telling, 40 deep learning techniques. How it is coming is how it is organized, what mathematics, so that we need to bring one new mathematics to the new layer suitable for that algorithm or suitable for speech application or image application. Or for example, one of my student, the highest innovation he has brought, voice cloning he has done. He has brought purely new mathematics, new approach that we are going to submit it in a good journal. So that I have taken one UK professor because I'm not speech specialist. He started conducting meeting and he started providing lot of advices, modifications. He's understanding that he's doing. I cannot understand. I am reading the paper, fixing the error and how to do, what are all the results need to be brought. That much only he said. How to improvise, that all I don't know. So newly mathematics need to play a role. New configuration we need to bring, or some new pre-processing technique we need to do. Because of my new proposed pre-processing technique only, the conventional CNN is performing well. That way we need to prove. Or hybridization, here off, break that and connect this, then that is called a new innovation.
I think hybridization will be easy when compared to mathematical modeling, madam.
Yes.
Thank you, madam.
Welcome, sir. Thank you.
Madam, Lakshmi madam, this is
Yes,
Dr. I. Sunita madam.
Yes, madam.
Madam, can you suggest which mathematical model is suitable for EEG signal, madam?
EEG signal altogether need to be done differently. EEG signal is time series data. With respect to time only we do. So RNN, LSTM, GRU, attention-based LSTM, by LSTM. These are all the 5 techniques applicable to use it in terms of deep learning.
Shall we use that EEG signal can be treated as image? Shall we apply for alpha, beta, gamma threshold?
Apply. Converting it into image means then it is said to be CNN only we need to use. Not possible to do. We need, it is time series data. This is best example. Already I said electrical data. Now you have brought one new example, that is time series data. If at all deep learning, it is only possible to use only deep learning. RNN, LSTM, GRU. Within LSTM, different versions are there. LSTM, by LSTM, attention-based LSTM. That's all.
So for classification, we have to select the alpha, beta, gamma values, ma'am.
Yes,
Finally.
ma'am. That all feature extraction. In that
Yes, ma'am.
EEG signal, these all are said to be feature. That features first we need to extract. After feature extraction, that feature we may need to pass it to any one of this model or hybridization of this model or standalone comparative study. These all. Or there may be a lot of algorithms. These are conventional ready-made algorithm I'm talking. In
Yes,
terms of
ma'am.
research, we need to sit and think and bring new model that will become research. For learning point of view, teaching point of view, we can apply ECG and these models. That's all, madam.
Thank you, madam.
ECG and EEG. We can apply this. Both are time series model. So RNN, LSTM, by LSTM, attention based. LSTM.
Thank you, madam.
LST. Yes, ma'am.
Thank you, madam, for your elaborate explanation.
Yeah, thank you very much, madam.
Participants, if you have any questions, please
Only
post.
organizing team is vibrant. Participants are sleepy mode.
Okay, thank you, madam. Shall we wind up, madam?
Yeah, yes, ma'am.
Thank
you for giving me an opportunity to be part of this FDP. I thank complete Annamacharya Institute from Tirupati for giving me an opportunity. And I thank all of the participants for your active listening in the late evening. I wish you all success, wish you a happy teaching, wish you a happy learning, because it's my concluding day. So that I'm wishing, and thank you one and all. Bye all of you.
Thank you,
Thank you,
madam.
madam.
Thank you, madam. Thank you.
Thank you, madam.
Thank you, madam.
Thank you, sir. Welcome. Ma'am, I am leaving. Bye.
Okay, madam.
Okay, madam.
Okay, good night, madam.
Good night, ma'am. Thank you.
Since 2 days, all the